Hello everyone, today in this video I'll be discussing the cryptography and network security super important questions. And if you learn all these questions, it's more probable that you will be able to score at least passing marks in the exam because these questions are the most repeated ones, okay? And when I say it is most repeated ones because it has been appeared in 21 scheme as well as 18 scheme. Both these schemes had the same subject, okay? And the syllabus is also almost similar. So there is a high chance that the pattern can repeat. Okay, so don't miss any of these questions. Watch this video till the end and grab a paper and pen to practice along with me. That would be the best approach. And before starting, please do like and subscribe. It helps me make more videos like this. And if you want the PDF of this, you can DM me on Instagram here. Okay, without wasting more time, let's get started. The first super repeated topic from the module 1 is Playfair Cipher. Okay, you need to know what is Playfair Cipher and how do you apply Playfair Cipher for the given key and plain text. Okay, so if you don't know anything about Playfair and Playfair Cipher, it is a way to change the letters. Okay, see, this is the plain text, right? Cryptography is written. We will be applying some method to change this text into some other text that is not understandable format using a formula. Okay, that is what Playfair Cipher does. It is the best known multiple letter encryption cipher is the play cipher which treats diagrams in the plain text as single units and translates these units into ciphertext diagram. That means each of these considered as single characters and those are converted to ciphertext. Okay. The Playfair Cipher algorithm is based on the use of 5 cross 5 matrix of letters constructed using a keyword. Okay. So since they have asked in the exam to apply its rules, also we need to know what are the rules in the plain text. Okay. I mean Playfair Cipher. Okay. First rule is repeating the letters are not allowed. Like for example, if balloon is there. Okay, basically what we do is we will be dividing whatever the plain text has we have been given into a pair of two letters. Okay, and these two letters, but if you observe carefully here we have double L, right? If there is a double L, we will be not writing double L as a single pair. We will be having to insert a bogus character here, so a X will be inserting. Okay, so after this L we'll be inserting an X, and after this L there is an O, and ON will be taken from here. So none of the characters should have the same letters together. Okay, that is the first rule. Second rule is if two plain text letters fall in the same. Okay, second, third, and fourth rule. Okay, these three rules I'll be explaining it using an example. Okay, because even if I read it, it won't make much sense. Okay, so basically, what are the data we have been given with? Okay, data means what are the things we have been given. Key will be given and a plain text will be given. Okay, so your first step would be very simple. If you listen one time very carefully, it will be sufficient for you. Okay, so key is given as monarchy. Okay, so what you have to do is construct a 5 cross 5 matrix. 5 cross 5 means 5 rows and 5 columns. So total number of cells would be 25. Okay, and as you know, in English alphabet there are 26 alphabets. Okay, so if you want to write A B C D till Z, we will be able to write, but one letter will be left out, and the left out letter here is J. Okay, we do not like J, so we'll be not writing J. Wherever it is J is present, we will be not writing it. And if in the key here is suppose that instead of monarchy it was jonarchy. Okay, if it was jonarchy, we'll be not writing J, we'll be writing I instead of it. Okay, J will always be replaced with I, and wherever if the J is going to come, we'll be replacing it with I. Okay, and if there is a key, like for example Apple. Okay, in Apple there is two same letters. Okay, we cannot write two same letters in the together, so we'll be writing APLE only. Okay, we'll be not writing two times, we'll be just writing a single time. Okay, so monarchy is present here, right? What we'll be doing is we'll be starting from here, we'll be writing MONARCHY. Done. After this we will be writing those letters which are missed in monarchy. For example, B. After A is present, we'll not write A again. B is not there, so we'll be writing here B. Then next letter after B is C. C is present, we'll not write C again. After D, we'll be writing here D. Then we'll be writing E, F, G. H is already present. I is not present, we'll be writing I. J we will skip, we will not write J. K, L, M is already present. N is already present. O, P, Q, R is already present. S, T, U, V, W, X, Y is already present, we'll be writing Z. So if you observe carefully, we are not repeating any letter from here, and we are missing one letter J. So and remaining and we are writing all the remaining letters in the remaining boxes. So it would ensure that it would be filled with all the letters. Okay, except J. Okay. Now after this is done, you have to use this to encrypt the following text. Okay, you have to make a matrix like this. That is the thing which we'll be using to encrypt it. Now, how do you encrypt it? The first thing is you will be dividing into a pair of two letters. Okay, CRYPTOGRAPHY. You will be dividing it. Okay, after dividing, you will be checking each pair in the matrix and finding the encryption. Now, you have to find the encryption of this, encryption of this, encryption of this, and for all the other pairs, you have to find the encryption. Okay, here one thing can come, like for example, if it was just cryptograph, okay, y was not there, so here one single letter will be there. After this letter you can add x. Okay, any letter you can add, usually we will be adding x here. Okay, so it will be hx. Now since it is even letters, they will be forming two pairs. Okay, a pair of two letters. Now we have to find the encrypted character for each pair. Okay, now for example, cr is present here. What would be the equivalent of cr? It would be dm. What would be the equivalent of YP? It will be HQ. Now you might ask the question, how did you write DM? How did you write HQ and so on? Okay, so there is a trick to it. Okay, not trick, it's the rule. CR, how do we write it? Okay, see, CR, you find out where it is in the matrix. Okay, C in this case it is present here, and R in this case it is present here. Okay, what you have to just do is check where it is in the same row. If you go in which column R is coming, that letter you take. Okay, I will repeat. C is present here and R is present here. Okay, what you do is you make a rectangle around it. See, if two things are there, you can make a rectangle or a square around it. Now once the rectangle or the square is made, what is your next step would be? Your next step would be, for C you want to find out which is the encrypted letter. Just go and take that which is present in the R column. Okay, so for C it will be D. Okay, like that you have to take. For C it will become D. Okay, that will be encrypted. Next is R, right? Because the second letter is R, we have to encrypt. The same thing you will do. In R, you will go in the same row. Wherever C is present, that column's letter you will take. So for D, it will, for R, it will become M. So for C R, it will become DM. Okay, that is the way you will be doing it. Yp, now just try yp where it is yp. Y is present here. Where is p is present here. So if you make a rectangle around it, yp is present here, just go down and take q from here, and go up and take h from here. So qh will be the sorry, yp is there, right? Yp means you have to not go down. Okay, that is the main rule. Okay, I forgot. See here, y is present here and p is present here. Okay, after you make a rectangle, you have to always go in rows. Okay, you will go in the row and you will take this letter, and you will go in this row and take this letter. So for y it will be h, for p it will be q, so for yp it will be hq. Okay, so for yp it will be hq. What about to? See, if we observe t is present here and o is present here. Okay, so if we make a rectangle or square around it, what we'll be getting? To is present here, right? So if you make that, we'll be getting, for t we'll be getting p, for O will be getting R. Okay, so PR will be the letter, encrypted letter. Same thing goes for GR. Let's see for GR where it is. G is present here, and R where it's present. R is present here. So if we go here in the row, we will be getting K for this, and if we go in the row here, we'll be getting N. So it will be KN. Okay, so here for GR it is KN. AP is OS, right? So see here, A is present here and P is present here. So go in the same row, you will be getting O, and for P you will be getting S. So it will be OS. And for HY it is YB. How come it is YB? See, HY is present here in the same row. It is present in same row. Till now, whatever we have encountered, it is present in different row and different column. So if it is present in same row, what you have to do is you have to take the next letter of it. Okay, means we want for H and we want for Y, right? These are the two letters. So take in the same row next letter. For H we will be taking Y, for Y we will be taking B. So for H it will become Y, and for Y it will become B. So YB will be the encrypted. Okay, YB will be the encrypted. Now write this all together. It will be DMHQPRKNOSYB. This is the encrypted text. Decryption, do the reverse of it. Okay, take this and divide it into a pairs of two. So it will be DM will be first, then HQ, then PR, then KN, then OS, then YB. Okay. DM, what will be doing the reverse? See, if we see DM where it is, DM is present here. First D is present here and M is present here. Okay. Now go in the same row and the same column. You will be getting two letters. For D you will be getting C. For M you will be getting R. So it is CR. Okay. So it will be CR. Next is HQ. Okay, so let's have a look HQ where it lies. H is present here and Q is present here. Go in the same row, you will get Y, and go in the same row, you will get P. So it will be YP. Okay, so this one will be YP. Like that for PR, we will get TO, KN will get GR, OS we will get AP, but YB it's in the same row. If you observe carefully, Y and B it is in the same row, right? Y and B it is in the same row. For decryption, we will be taking the previous letter. So Y will become H and B will become Y. So it will become HY. Okay, so in this way for the YB it will become HY. Okay, so that decrypted is again we will get as cryptography. Okay, so here you learned two rules. One is if it is in the same row, what you have to do, you have to take the next letter for encryption, and if it is in the different row and different column, you'll be making a rectangle and traveling across the same row until you reach in the column where the other letter is present. Take that letter. Like that only here also you'll go back and take that letter from which it is in the same column. So like that you'll take and write all these. You'll be encrypting and decrypting. Okay. Next example we'll be looking here. Some other rule will be there where the same column is present. In that case, what you have to do. Okay, and also we'll be looking last letter we have to add. Okay, see, the keyword given is monarchy. The method given is to use playfair, and the plain text given is instrument. Okay, first step is monarchy. We will be writing here MONARCHY. Same as previous one. We'll be writing B here, and C is already present here, so we'll be writing DEFG. H is already present, so we'll be writing I. J will not write, we'll write K, L, M. M is already present, and O is present, so we'll be writing P. Q, S, R is already present, so we'll be going with S. T, U, V, W, X, Y is already present, so we'll be writing Z here. Now, using this, we'll be dividing the plain text into pairs of two. So we'll be writing INSTRUMENTS. Now, S is already present here, means just a single character is present. We have to add another character to it. So we can either add an X or we can add a Z. So in this case, I'm going with Z. You can add X also. It's also the right answer. Okay. So we have got the pairs of two characters. We'll be taking the encryption of it. Okay, so IN's encryption will be what? IN wherever it is present. I present here and N is present here. So make a rectangle here. Once you make a rectangle, go in the same row and go in the same row, you will be getting GA. Okay. ST. Where is S? Where is T? S is present here and T is present here. So if it is in the same row, what we will have to do? We have to take the next letter. For S, we will take T. For T, we will be going next and we will be taking this letter. What is this letter? It's nothing but L. Okay. Going again here means we are starting again from here. Imagine this as a repetitive infinite row. Okay, where here it will be after T, it will be again L, P, Q, S, T, again it will be L, P, Q, S, T, and from here it will be T, S, Q, L, P. Okay, like that is keep repeating. Okay, L, P here. Like that it's keep on repeating. So after T, what is there? It is L. Okay, again it is coming back here. It is a loop. So for S we will take T, for T we will take L. So TL will be the character. Okay, RU we will take. Where is R? Where is U? R is present here and U is present here. Make a rectangle here or a square, and for RU you want to take, so R will be going with M and U will be going with Z. Okay, so RU will be MZ. Okay, next is ME. ME, if you observe, this is a new case where we have M here and E here, it is in the same column. So if it is in the same column, the same thing you will do. For M you will take C, for E you will take L, so it will be CL. Okay, and NT and SZ, this is straightforward. NT will be here and SZ also will be here. See, SZ is present here, right? So we'll make a square here. S we will go with T and Z will go with X, so it will be TX. Okay, so the encrypted one will be GA TLMZ CLR2 TX. Okay, now for each letter we will be taking the decryption. Okay, first we have to encrypt it, again we have to decrypt it. To decrypt GA, how we will be decrypting? See, for the GA, if you want to decrypt, G is present here and A is present here. If you make a rectangle from here, for G it will become I, for A it will become N, so it will be IN. INSTRU. For CL we have to take a new one here. See, new one means in this example we have to discuss it. It's the same column. So if CL is in the same column, we will be taking the above letter. Okay, because we have taken the previous next letter below it for the encryption. For the decryption, we will be using the letter which is above it. So it will become for CL it will become M and E. Okay, so it will be ME. Okay, like that RQ will be NT and TX will be SZ. Okay, after doing that, the decrypted text will be writing together INSTRUMENT SZ. Okay, so SZ, this one we had already added, and it doesn't make sense to have instruments. So we'll be cutting off Z at the end, we'll be writing instruments. Okay, also you can write Z here, that also doesn't matter, you get the. Okay, this is how play fair cipher algorithm works. Very simple one, just remember the rules and you can follow the method which I have.
The next one we have, the most repeated one, is the Hill cipher algorithm. Okay, so let's discuss what is Hill cipher algorithm and how do you use it. Okay, so let's get started. See, Hill cipher is algorithm where you will be having a plain text. Okay, in this case plain text given is safe messages and we are given with the key ciphering. Okay, now there are two ways in which this question can be asked. Okay, either they can give you the key as letters or they can give you the key as matrix. Okay, so if they give you as letters, in that case you can directly proceed. Okay, you need not sorry, if they give you letters you have to convert it into matrix, and if they give matrix you can directly proceed. Okay, so the terms which will be used here is C means ciphertext, P means plaintext, K means key. Okay, and the formulas will be, to find out the ciphertext we have to multiply K with P and mod 26 we have to do, and if you want to find out P, we'll do K inverse into C and mod 26. Okay, and how to convert letters into the numbers, we will be using this formula. We will be starting from 0 1 2 for ABC till Z, we will reach 25, and we will be assigning each letter a number. Okay, so we'll be writing it like this: CIPHERING, the key which is given to us. Ciphering, we will be writing CIPHERING, and we will be substituting for each letter what is the number numeric equivalent. Okay, like C is 2, right? So we'll be writing 2 here. I is how much? It is 8, so we'll be writing 8 here, and so on. We are ready with the K. Next step is to write the P, which is the plain text. Okay, always we will convert plain text to ciphertext. Okay, so now after we have the plain text, what you have to do, we have to divide the plain text into length of 3 vectors. Okay, 3 length means SAF, EME, SSA, GES. Okay, means first 3 letters, then next 3 letters, then next 3 letters, then next 3 letters. Okay, the question will be given as such, which will be a multiple of 3. Okay, so don't worry about that. Now after you have done that, what you have to do is you have to convert each of these letter to the numeric equivalent, seeing the above table. Okay, and you have to do it for all the vectors here. Okay, they can ask you 2 cross 2 matrix also. In that case the vector length will be 2 2 length. Okay, means 2 2 pairs it will be. So how much ever the length the matrix is, if it is 3 cross 3 you will be having the vector length 3. If it is 4 cross 4 you'll have the vector length 4. Okay, how do you know what to do? So if they give you like 12 letters, sorry, 9 letters are here, so it will be 3 cross 3, like that. Okay, see, 3 3s are 9, 2 2s are 4, 4 4s are 16. So how many letters of key they give, based on that you have to find out what would be the size of the matrix. Okay, after that you have converted into the length vectors. Now we have to apply this formula, which is C is equal to K into P mod 26. Okay, now what is K? K is nothing but the vector which we have gained here, which we have obtained here, and multiplied by P. P means for each of these letters I have to find an encryption. Okay, so this will be encrypted, this will be encrypted, this will be encrypted, this will be encrypted. 4 encryptions will be there, so 4 encryptions I have to do. I'll be substituting this here. First encryption I will do for SAF. What will be the encrypted letters for SAF? How do we find out? First write K here, then write that P here, and then do the matrix multiplication. How do you do matrix multiplication? See, this what is the dimensions of this matrix? 3 cross 3, right? And the dimensions of this matrix is 3 cross 1. So the final matrix would be the column of this, sorry, the length or the number of rows present here into the number of columns present here. Okay, let me write it again: 3 cross 3, and this is 3 cross 1, right? So the final matrix should be 3 rows and 1 column. Okay, 3 rows and 1 column. You have to take the rows from the first matrix, number of columns from the second matrix. Okay, that would be the dimension of the final matrix. Now how do you multiply? For multiplication of the matrix, you have to multiply the first row with first column, then you have to multiply the second row with this column, and you have to multiply the third row with this column. Okay, now how do you do that? First you will do 2 into 18, you will be writing 2 into 18 plus 8 into 0 plus 15 into 5. Find out this answer and write it is 111. Next, 7 for 17 into 1805. Same way, 18 into 7 first, 4 into 0 next, 17 into 5 after that here. The last one also is same, 18 into 8 plus 13 into 0 plus 6 into 5. Okay, and you'll find out this answer. Do mod 26. You know what is mod 26? Mod 26 means you will be dividing 111 by 26. Okay, once you do that, what is the remainder you get, that you have to write here. Okay, so the what number you have here, convert that into the letter equivalent. Okay, you will get a letter here. Same thing do for this one also, and this one also will get two more letters here. Therefore the encryption for SAF is HDS. Okay, that would be the conclusion. Like that you have to do for EME, SSA and GES. The four vectors we have got here, right? For each of these four vectors you have to follow the same procedure, and you will be getting here four different matrices. Okay, next what you have to do is you have to combine the following vectors. Okay, HDS, IOE, YQO, CAA. So you'll be writing it together, and this is the encrypted text. First part of the question is to find encrypted text. There is 5 marks for it. Okay, this is 5 marks. Next 5 marks would be for decryption. Okay, and let me tell you, decryption is a little bit harder. Okay, decryption is a little bit harder. Okay, now how do you decrypt it? You have to use this formula: P is equal to K inverse C mod 26. C is these letters here, which will be converted to numeric equivalent as we have here. Each of these numeric equivalent will be taken into consideration. And what is K inverse? That is the main thing in this um, decryption. Okay, we have to find out K inverse. Let's see how do we do that. There are a couple of steps which you need to follow to decrypt the text. Okay, so firstly we need to find out what is K inverse. Okay, so how do we find out what is K inverse? See, to find out K inverse we will be using this formula: D inverse adjacent of K into mod 26. Okay, and what is the D inverse? To find out D inverse we have to use D into D inverse mod 26 is equal to 1. For that, what we need to do, what is D we have to find. Okay, so it would be as follows, don't get confused. To find out K inverse we need to use this formula. In that we have D inverse. To find out D inverse we need to use this formula. In that we have D. For finding out D we have this formula. Okay, so D is nothing but determinant. Okay, you have the same K, right? Whatever we had K here, 2, 8, 15, 7, 4, 17, 8, 13, 6. The same thing we have here. You have to find out the determinant. How do we find out the determinant? To find out determinant you have to take this and ignore this first row, first column and first row. Okay, and multiply these two. What we will be getting, 4 into 6 into minus 7 into 13. Okay, so this is not 8 into 17, this is, just a second. Okay, 2, 8 and 15, right? So it's actually not like this. Let me correct it. See, how do you find the determinant is you will be taking 2 and ignoring the column and the row. Okay, and you will be multiplying 4 into 6 minus 7 into 13. Okay, so it would be 4 into 6, 4 into 6 minus 17 into 13. Okay, and you will be having here minus. See, this is plus. Okay, first one will be plus, second will be minus, third will be plus. Okay, so this will be 8 into, you will be ignoring the column and the row, 7 into 6 minus 17 into 8, 7 into 6 minus 17 into 8, and here we will be having minus 8, plus 15 into 7 into 13 minus 4 into 8, 7 into 13 minus 4 into 8. So if you calculate this, will be getting 1243 here. Okay, let me just calculate and see if we actually get it. So we'll be getting 1243 only. Okay, so just it was a writing mistake. Okay, so this is the correct one. Okay, this is how you find out the determinant. And when you got a determinant here, we will be using this determinant in this formula. Okay, means previous to this, what is the formula? D inverse mod 26 is equal to 1. So we'll be writing here D into D inverse mod 26 is equal to 1. Here what you have to do is substitute the value of D inverse starting from 1. Okay, so if you do 1 to 3 into 1 mod 26, will you get 1 or not? If not, move to the next one. Try that. If not, move to the next one. Try that. Till you get. Okay, that is a trial and error method. So in this case, 1, 2, 4, 3 into 5, whatever answer we get, if you divide by 26, we get a remainder 1. So 5 is the value of D inverse. Now we have got D inverse. You will be using D inverse is in this formula, but in this formula we have adjacent of K, right? So how to find out adjacent of K? Sorry, not adjacent, it is adjoint of K. Okay, how do we find out adjoint of K? For that you have to do again the same thing only. You will be ignoring the row and the column. Okay, and you will be multiplying 4 into 6 minus 17 into 13. You will be writing it here. Okay, next, if you want to know what you have to substitute in this place, you will be ignoring this row and this column. Multiply 7 into 6 minus 17 into 18. That answer you will be writing, and this place you will be writing minus. Why? Because it is like this. Okay, it is alternate. This is plus, this is minus, this is plus, and this is minus, this is plus, and this is minus, this is plus, and this is minus, and this is plus. So it is alternate. You can go in this way. Okay, plus minus plus, and plus is here, so it will be minus, this will be plus, this will be minus, and this will be plus, this will be minus, this will be plus, like that. Okay, whichever sign is there, that sign you have to add it here. Okay, same thing you do for this also. If you want to find out what you have to substitute in the place of 15, ignore the row and column. 7 into 13 minus 4 into 8, you will be writing it here. Same thing you will do for all the elements. Okay, and you will find out an answer. Now this is the adjoint of K, but we need to find out the transpose of it. Okay, the actual adjoint is the transpose of this matrix. Transpose means this row and this columns are present here, right? What you have to do is take this row here, take this row here, take this row here. That's it. Okay, that is how you do the transpose of the matrix. Now once you have the transpose of the matrix, that means you have the adjoint of K, you have D inverse. Now we have both of them, we need to multiply both of them. Okay, we'll multiply both of them. So D inverse value is 5, adjoint of K is this, and we have to find out mod 26. How you will do that? Multiply 5 with each of these elements. 5 into 197 right here, 5 into 147 right here, 5 into 76 right here, and so on. After that, do mod 26 for each of that answers. What reminders you get, write those reminders here. Now we have the value of C. Okay, now after sorry, we have the value of K inverse. Okay, this is the whole value which we find out. This is the K inverse. Now you have to use K inverse and C to find out the value of P, which is decryption, right? What is the initial letters we had? We have to get it. So we'll be using each of these C. There are 4 C's here, right? This is the 4 encrypted text for the 4 uh, vectors we had initially. So we'll be taking each of these and decrypting it. Okay, so K inverse into C mod 26. So this is K inverse, this is C, this is mod 26. Find out the answer, you will get some numbers. Convert it into the letters, you have to get SESAF. Then for the next EME, safe messages, like that. Okay, so that will be the decrypted text. It is a bit lengthy one, so if Hill cipher comes, if you're good at maths and you know you can solve it, you have that much time, then only go for it. Okay, otherwise go for play cipher. Okay, or go for any or question. Okay, because it's a bit lengthy one. Let's look at another one, the same one, wherein we are given with directly a matrix. Okay, and this same question has been repeated many times. Pay more money. Okay, it's a famous question. So at least if you learn this, however it is, if you memorize some values, okay, if the same question comes, it might be helpful. Now how do you solve this? Before that also they have asked explain Hill cipher algorithm. Okay, first read the question, don't simply go and start writing answers. Okay, see, in the previous one they had not given explain Hill cipher algorithm. Directly they had asked using Hill cipher perform the encryption and decryption for plain text. In the other question they have given here, so it means that you will be getting marks for explaining what is Hill cipher also, and it's total of 10 marks. That means it will be of like 3 marks here, this will be for 4 marks, decryption can be of 3 marks, so it will be total of 10 marks, right? So it is in that way. So if you skip this, you will get 7 marks even after solving all of this. So make sure you read the question first. Okay, now the steps should be as follows. The Hill cipher is a polygraphic substitution cipher based on linear algebra. Okay, just let me change the marker. Okay, now see, It is based on polygraphic substitution cipher based on linear algebra. We are using linear algebra, in which blocks of plain text letters are encrypted using matrix multiplication modulo a fixed number. 26 we are using because there are 26 letters in English alphabet. Now the steps would be as follows. You have to select the key selection. Choose the square key matrix K of order n cross n. It can be 3 cross 3, can be 2 cross 2. Okay. And invertible modulo 26. You have to choose which matrix we have got that is invertible of 26. Okay, all the matrices are in modulo 26, it is there. So I mean 26 it will be decrypted. Okay, so don't worry about that. You can take 3 cross 3, 2 cross 2 matrix. Okay. Next, plain text preparation. Remove the spaces and punctuation like in the safe messages. Okay, like just we saw safe messages was here, right? So here we remove the space. Okay, whatever punctuation is there, remove that. Convert all upper letters to uppercase. Okay, so that it will be A and B. It will not be like that. It will be a standard one. Okay, like that. Next, if plain text length is not a multiple of n, append filler letters, usually x. Okay, suppose that I told you, right, the what thing they have given, that would be multiples of n. Whatever the size of matrix is there, if it is 3 cross 3, the plain text which is given will be in the multiple of 3. If it is not, put x. Okay, so after that, what you have to do is you have to divide the plain text into the blocks of size n. Means it was like 3 cross 3 matrix, right? So we'll be dividing into the vectors of 3 3 3 like that. Okay, now letter to number conversion. Start from a is equal to 0 till z25 and convert each of these to the numeric equivalent, and after that compute the ciphertext using this formula. C is equal to k into p mod 26. Convert the numerical value of c back into letters. We'll get a number here, convert back into letters using this formula. Okay. Then decryption algorithm is computing the inverse of this matrix, k inverse modulo 26. Divide the ciphertext into blocks of n, each ciphertext into a block or column vector of C. Compute the plain text using this formula k inverse C mod 26, just as we saw previously, and convert the numerical values P back into letters. Okay. So let's have a look at another question. In this question, what is the matrix given to us? There is numeric matrix, so we need not convert from any letters to numeric. Previously, we had been given ciphering, so we had created a matrix of ciphering and then converted into the numbers. But here the numbers are only given. Both of the question can come, so be prepared for both of them. Okay. Now this is the plain text given to us. Pay more money. Okay, so we'll be taking that plain text first. Firstly, we'll be writing the formula. C is equal to ciphertext, P is plain text, K is key. This is the formula for calculating C. This is the formula for calculating P. These are the letters you have to write. The vector should be as follows: P A Y M O R E M E E M O N E Y. Okay, and convert it into the numeric equivalent using the above reference. And after that, we have to find out C is equal to KP mod 26. And what is K? K is the matrix which they have given to us, and P is nothing but we'll be taking each of these one by one. First, you will be doing it for pay. Find out the answer, you will be converting into the letters. Do the same for M O R E M O and N E Y. You will be obtaining 4 letters. Combine them, you will be getting the encrypted text. To decrypt, we have to find out K inverse C mod 26. Firstly, we need to find out K inverse. We'll be needing this formula D inverse adjoint K mod 26. To find out D inverse, we'll have to find out first D. So what is D? D is nothing but the matrix which they have given. Find out the determinant. If you don't know how to find out determinant, refer the previous question. They have explained in detail. Okay. After you have found out the determinant, it can come either a positive determinant or negative determinant. If it comes positive, you have to directly take mod 26. If it comes negative, how to take mod 26? What you have to do is, if it comes negative, first make it positive. Okay. 939. Do 939 mod 26. Whatever answer you get, in this case you get the answer 3. Okay, so you'll be subtracting 26 minus 3, because you're doing mod 26. You'll be subtracting 26 minus 3. What answer you get? That is the modulo of minus 939. After you have got the determinant, you substitute this value here and find out the D inverse. How do you find out the D inverse? You will be multiplying 23 into 1 mod 26 and finding out the remainder. 23 into 2 mod 26, finding out the remainder. Like that, you keep on do till 17. Okay, once you do till 17, you will be getting the 23 into 17 mod 26 is equal to 1. Okay, so you'll get the value of D inverse as 17, and then we'll be finding out the adjoint of K. To find out the adjoint of K, I've explained how you have to do. Ignore the row and column, multiply this and subtract with the multiplication result of 21 into 2. That answer you'll be writing here, and the minus signs are nothing but just here. Okay, these 4 places you have to add minus also at the end. Okay, and if by answer only it is coming minus, keep it as such. Okay, and if by answer minus is coming, another minus you have added, minus minus will become plus. Okay, I think that's basic algebra. Okay, and you'll get an answer here. Do the mod 26, keep it here. Now take the transpose of it. Transpose, how you will do: 1425 7, put it here. 718, you put it here. 621, you put it here. You'll be getting the transpose. This is the adjoint of k. Now we have both the d inverse and adjoint of k. Multiply both of them, do the mod 26, you'll be getting an answer here. This is k inverse. We have k inverse and c. We will be finding out the decryption for each of these letters. Encrypted letters will be converted into the numbers. We will be multiplying k inverse into c mod 26. We'll be getting some letters. Same thing you do for the HDL, EWM, and TRW. After you have got that, convert back into letters and combine it. You will be getting the decrypted text. Okay, so go for Hill cipher only if you are good at maths and you have time. Okay. The next most repeated question is: explain the Fiestal cipher structure, encryption and decryption with a neat diagram. Okay, so firstly we need to write what is the Fiestal cipher structure. Okay, it is a symmetric block cipher structure used in many encryption algorithms such as DES. Okay, DES also an important question, we have to know about that also. So let's analyze this one, what all you need to write. Okay, so it divides the plain text block into two halves. Okay, and applies a round function repeatedly to achieve encryption. This means the whatever the plain text will be given to us, it will be first divided into two parts. The left part will be written as L and the right part will be written as R. Okay, and a round function will be repeatedly applied to it. So a function f will be there which will be applied to that plain text. Okay, and the same structure is used for both encryption and decryption, differing only in the order of round keys. Okay, so let's understand each process one by one. First one is the encryption process. Okay, so the plain text block which we have been given, it will be divided into the left half and the right half. Okay, and cipher consists of n rounds. Okay, and each round has the following operations: Li will become R of I minus 1 and R of I will be L of I minus 1 XOR function of Ri minus 1 and K. Okay, so I'll explain what all is this using a diagram. Now see, input text plain text has come here, the input plain text. This is divided into two parts, left part and the right part. Okay, so follow the arrow marking. Okay, see, arrow marking is going here and it is going to this operation here. This is the XOR operation. Okay, so for the XOR operation, two inputs are required. The first input is the left part of the input. Okay, if it is 64 bits, it will be divided into 32 bits and 32 bits. Okay, so the left part 32 bits will be going to the XOR is the first input. Second input is the right part will be first going through a function. This function will be performing some operation along with a key k1. Okay, so it will be performing an operation along with the key k1 and that will be going to XOR as the second input, and that output is taken as the RE part. Okay, that you have to understand. What is the output of this? The output will always be taken as RE part. Okay, it will be like an alternate. The first output which you get, that will be the that will be taken as the right part and it will be going to the function f, and the k2 will be the second key, will be performing an operation with the re, and that will be taken to the XOR, and as the previous one, which is the left part, it will be going as such only, it will not be performed, means operation will not be performed on it. Okay, the answer which is there, that will become the right part. Okay, and the other part which is the left part will be keep on going like that. In the next operation we will be taking this part as the left here, and the remaining one which is the right part, that will be going through the operation. So it will be keep on going in this way, in the alternate ways, and finally we'll be having an answer after 16 rounds. Okay, and after the 16th round, the left part will be sent to the right part and the right part will be sent to the left part. So that output will be the cipher text. Okay, you got the point, right? Firstly, the input text is divided into two parts, left and right, and the left part is taken directly to the XOR. Right part goes through an operation with key K1 and goes to the XOR. The output of XOR is taken as the right part, which again goes through the operation and goes to the output XOR, and the left part will be taken as such only, which was initially the right part. Okay, and that output will be taken as the right part here, and again it will go through the operation with another k value, and the other part which was left, that will be taken as left part and it will directly go to the XOR. So it keeps on going until we come here, and after 16th outputs, we'll be exchanging the left part and the right part and we'll be obtaining a ciphertext. Okay, for the decryption also the same thing will happen. The input will be taken from here, which is nothing but the ciphertext which you have got from here, and that one will be taken, the left part will be taken as directly here, and the right part will be going through an operation. For the k16 value, it will be taken, and it will going to the XOR, and the output will be taken as right part, and that will again go through the operation, and the left part will be taken as such, and the output again will be going from here as the right part. It will be going through an operation, and the XOR will be taken from the left part here. It will keep on going until you reach the 16th or the 0th operation. We are starting from the 16 and reaching 0. Okay, we'll be using K16, K15, K0. Here we are starting from K1, K2 till K16. Okay, so after we reach till the first part here, we'll be exchanging the left and the right part, and that will be and in that way we will be obtaining the plain text here. Okay, so this is the process you need to write. For the decryption, the information will be as follows. The ciphertext is divided into two parts, ln and rn, and ri will become the li, and li will be nothing but the operations result. Okay, so after completing all the round, the original plain text is recovered. This much things you have to write. Also, you have to also include the design features. The marks are there for this also. Okay, don't skip this one. There are few design features. The block size is important. We are taking 64 bits, right? We cannot take more, we cannot take less than this. 64 is the number which is designed, which is considered reasonable trade-off. Okay, and key size, that also cannot be very high and very low. Why? Because the key size which we are putting here, if you are putting very big key, it will take a lot of time. If you are putting very small key, it is easily hackable. So you have to put a key which is in between. Okay, the size should be in between, uh, very high and very low. Okay, and the number of rounds should be 16. That is a typical size which has been observed to be giving a proper result, efficient result. Sub key generation algorithm, see, after each round we are getting a new key, right? K1, K2, K3. These are generated by sub key algorithm. Okay, so that algorithm has to also be defined. And we have round function. Inside each we have a f, right? So that function we have to define in such a way it should not be complex, but if it is complex also, we should be able to understand and analyze it. Okay, so it means crypt analysis should be possible, but the crypt analysis should not be so easy that it would be analyzed by hackers also. Okay, fast software encryption, decryption, the whole process should take less time, otherwise it will become very hard practical users. Okay, because if it's taking more time, we cannot scale it. Means for large inputs we cannot do it, it will take a lot of time. We want faster software encryption and decryption. Ease of analysis, the analysis should be easy, but not that easy that hackers also can analyze and hack it. Okay, it should not be that easy. So this is all you have to write about the Fiestal structure, encryption and decryption. Okay, and diagram also you have to make. The next question is the DES encryption algorithm. Okay, this is also a very highly repeated topic. Okay, so in this they have asked explain with a neat diagram. Okay, so we need to make a diagram also. Before that, let's understand what is data encryption algorithm. Okay, so it is a symmetric key block cipher that encrypts 64-bit blocks using a 56-bit secret key. Okay, so the key which is going to be used is 56 bits. Okay, and the data which is present is 64 bits. It will be divided into two parts, 32 and 32. Okay, that we already know from the Fiestal structure. DS is based on Fiestal cipher structure that performs 16 rounds of encryption to produce a ciphertext. Okay, so the overall structure of DS encryption, the input plain text would be 64 bits, effective key size would be 56 bits, the number of rounds would be 16. Each round uses a different 48-bit round key. Okay, we'll be using the different round key also. Okay, inside that we have another round key as well. Now the initial permutation means 64-bit plain text is permuted using a fixed initial permutation table. The output is divided into left 32 bits and right 32 bits, means it is mixed. Okay, it is not sent as such, it is mixed. Okay, permuted. Next 15 Fiestal rounds will be there from I is equal to 1 to 16. In each Li will be equal to Ri minus 1, and Ri will be equal to Li minus 1 XOR operation of the function which is the round key function between the Ri minus 1 and Ki. Okay, so Ki is the 48-bit round key and F is the DS round function. Next, after that we will be taking the function F in detail. Okay, what's happening in the function F? The expansion box happens in which the 32-bit I minus 1 is expanded to 48 bits. Okay, then key mixing happens where the XOR expands the data with the round key Ki. Okay, and then substitution happens. The 48-bit output is divided into 8 6-bit blocks because 8 6 are 48. So 8 blocks will be there. Okay, 8 blocks will be there, and each block is passes through an S box producing 4 bits. Total output would be then 32 bits. Okay, 48 to 32 it will be reduced. Then permutation happens, the rearranging of the 32 bits to increase the diffusion, and final permutation would happen at the 16th round. The half values are swapped. As you remember, the left and the right in the Fiestal structure were getting swapped at the end. That's what is mentioned here. And the combined block is passed through the final permutation, which is the inverse of IP. Okay, This output is a ciphertext. If you understand it using a diagram, here each time we will be having a 64 bit. The second round also will be having an input as 64 bits, and till the end the 32 bits will be swapped, but still it will be 64 bits, and inverse initial permutation will happen at the end, which will be the ciphertext. And in each case we are getting a new key. The key is generated using 48 bits. The 48 bits is the key size, and it's generated using a sub key which is 56 bits. Okay, so permutation will happen, 56-bit key will be generated, and the permutation will again happen, which will generate the K1. Like that all the keys are generated. This is the diagram you need to make. Okay, the next one we have is define cryptography and explain symmetric cipher model. Okay, so what is cryptography? It is the science and art of securing information by transforming it into unreadable form. Okay, whatever is there understandable readable form, will be transforming it into unreadable form and non-understandable form, so that the only the authorized parties can access and understand it. Okay, that is called as cryptography. Now the simplified model of symmetric cipher model. Okay, this is the first diagram you need to make. The plain text will be the input, which will be gone into the encryption algorithm like DES, and there will be a secret key which is shared by the sender and the recipient. This is the recipient. Okay, they both will have the key. Okay, what will happen, assume that this is a box. Okay, locker box. Okay, so a plain text will be put inside this box and key will be locked here, and that will be sent from here. Okay, now no one can read from outside what the plain text data is, but here the other person also will be having the key. They will be opening it and they will be able to read it. So this is how the basic fundamental of cryptography is, how the encryption and decryption works. Okay, this is encryption, this is the decryption. Now what all it has the plain text. Okay, that is the first thing, which is the original intelligible message or data that is fed into the algorithm as input. Encryption, the algorithm performs various substitutions and transformations on the plain text. Secret key is also added as an input to the encryption algorithm, which makes it secure. Okay, the key is a value independent of the plain text and of the algorithm. The algorithm will produce a different output based on a different key. Okay, if we use different key, we will be getting different output, and the exact substitutions and transformation performed by the algorithm depend on the key. What is ciphertext? That is the output, which is a scrambled message produced as output. It depends on the plaintext and the secret key. For a given message, two different keys will produce two different ciphertexts. The ciphertext is apparently a random stream of data, and as it stands is unintelligible. Okay, decryption algorithm, it is essentially encryption algorithm run in reverse, so that we'll get the plain text back from the ciphertext. Okay, now another definition, distinguish between confusion and diffusion cipher, block cipher and stream cipher. This is also much repeated one. Okay, so what's the difference? Confusion and diffusion. Okay, confusion means it hides the relationship between plain text and the key, and diffusion means it diffuses means spread. Okay, just remember the keyword spread. Diffusion spreads the influence of one plain text bit over many ciphertext bits, and the purpose is to make the discovery difficult. This diffusion's purpose is to hide the statistical structure of the plain text. How this plain text would look like is it a small plain text or large plain text, we'll not know. Why? Because it will spread and make it large. Okay, so we'll not know the exact size. Substitution techniques are achieve the confusion, and permutation and transposition techniques achieve the diffusion. It changes the symbols without spreading, it spreads the plain text redundancy. Okay, example are substitution cipher, and the example for diffusion is permutation cipher. Now what is block cipher and stream cipher? Block cipher encrypts data in fixed size of blocks, and stream cipher encrypts data one bit at a time or one byte at a time. Okay, and the data size is fixed block size, and this is continuous data stream. Okay, and it's slower compared to the stream cipher, and it is faster and efficient for real-time data. The stream cipher is faster. Okay, and errors affect the entire block. If an error is there, the entire block is affected, but if any error is here, since it deals only one byte at a time, only those bytes will be affected. Examples are DES and AES, and the example here is for the stream cipher is RC4. Okay, moving on to the module 2, we have not much topics, but the topics which are there, you need to understand it in very much depth. Okay, so let's get started. See here, the first thing which you need to understand is the crypto system. Okay, the public key crypto system and its applications they have asked. Okay, but it's not just like they will ask applications. Okay, they can ask principles also, they can ask you the ingredients also. There are 6 ingredients of them. You have to all, they can also ask the authentication and secrecy. Like that, many questions are there. I'll tell you all that which can come in exam. Okay, based on the previous paper analysis. Now what is public key crypto system? Okay, so in public key crypto system there will be a system where we have a sender and a receiver, and both of them will be exchanging the messages, but there will be two keys. One is shared key, one is the shared key which is public key, and one is the private key. Okay, we'll be using these two keys to encrypt and decrypt. Okay, so listen carefully. The concept of public key cryptography is invented for two most difficult problems of symmetric key encryption. First is key exchange problem, second is trust problem. Now, the principles, if they ask, you have to describe these two. Okay, so the key exchange problem arises from the fact that communicating parties must somehow share a secret key before any secure communication get be initiated. Both parties must then ensure that the key remains secret. Of course, direct key exchange is not always feasible due to risk of inconvenience and cost factors. Now see, if there is a box here, okay, and it has a key, okay, and there is the box has to be shifted to this place, okay, from here to here. What if the box itself has a key in it, okay, and we'll be giving this box and key to a traveler. The traveler will be traveling and giving it to the receiver, but there is a chance that the traveler can open it in the middle of the path and hack it, right, and leak the information. So that is not feasible. The other option is both the sender and the receiver will be having two keys here, and once the box reaches here they can open it. But since they have these two keys and the keys open the box directly, anyone can make the duplicate of it also and keep it along with them, and inside the middle of the path they can open it. That is also not secure. So key exchange problem is not possible. Okay, that's the one problem. Second is trust problem. Ensuring the integrity of received data and verifying the identity of the source of the data can be very important. Means in the symmetric key cryptography system, receiver does not know whether the message is coming from a particular sender. Suppose that the sender has sent the a box and the receiver has received the box, but a traveler had the box for a while. Okay, so what could happen is the traveler could have opened the data, took out the real data and put in some fake data and again logged it and sent it to the receiver. So receiver will be seeing that the box is locked and he might think that it is genuine, but that scenario could have happened in between wherein the traveler would have changed the data from there. So that is another problem, which is trust problem. So the first one is key exchange problem, the key can be leaked. Second is trust problem, the traveler can alter the data in between. So because of these two things, we have to design a crypto system which will be secure against these two things. Okay, so public key crypto system uses two keys as a pair of encryption for plain text and a decryption of a cipher text. Okay, now these two keys are named as public key and private key. Okay, the private key is kept secret, whereas public key is distributed widely. Public key everyone will have, but private key only the person who is to be receiving the data, they only will be having. Okay, a message or text data which is encrypted with a public key can be decrypted only with a corresponding private key. So this is the box. Using the public key, it has been locked, and this can only be opened using a private key, not with a public key. Public key is just for locking. Okay, now this two key system is very useful in the areas of confidentiality, secure and authentication. Okay, now what are the applications of public key crypto system? These are characterized by the use of cryptographic algorithm with two keys, one held private, one available publicly. As discussed, depending on the application, the sender uses either the sender's private key or the receiver's public key or both to perform some type of cryptographic function. So the use of public key crypto systems are into three categories. In the three places the application is there. First is in encryption and decryption. The sender encrypts a message with the recipient's public key. Second is digital signature. The sender signs a message with its private key. Signing is achieved by cryptographic algorithm applied to the message or small block of data that is function of the message. Means once it is locked with a private key, that means a signature has been put on it that no one else can open it unless those who have the private key. Okay, and the private key is only with the receiver. Next, key exchange. Two sides cooperate to exchange a session key. Several different approaches are possible involving private key of one or both parties. Okay, so applications include RSA, you have to write, elliptic curve, Diffie-Hellman and DSS. Okay, now these are the applications of the public key approach system. I know that like still now it is not much clear what it actually means and how it works. Okay, so that's why for that there is a separate question. In case they ask you about the explain public key crypto system and its applications. If they ask you about the principles, if they ask you about the requirements, I'll be showing you what you need to write. Okay, requirements or ingredients. Okay, if they ask you about the requirements, or if they ask you what are the 6 ingredients, okay, it has been come in the previous year paper. If they ask in this way, you have to write this one. Okay, so what all things include in this whole scenario? Plain text will be there, which is a readable message or data that is fed into the algorithm as the input. Encryption algorithm, which encrypts the data, encrypts the plain text. Public key, this is the pair of keys that has been selected, so that if one is used for encryption, the other is used for decryption. Same key cannot be used for both. Okay, one is encryption, one is decryption. So that is the private and public key. Okay, ciphertext is a scrambled message produced as the output. It depends on the plain text and the key. Based on the combination of plain text and the key, a ciphertext is generated, and for a given message, two different keys will produce two different ciphertext, as it's obvious. Decryption algorithm, the algorithm accepts the ciphertext and matching key and produces the original plain text. Okay, now the third type of question which can come is, they can ask you to explain authentication and secrecy in public key crypto system, okay, with a relevant diagram. Now this using this example, much of the things will be clear. Now see, public key cryptography for providing confidentialities, which is secrecy. There are two concepts here, which is one is authentication, another one is secrecy. Secrecy means whatever the data is being sent from the source to the destination, that remains secret till the end, that is called as secrecy. Okay, authentication we'll discuss after this. Now what happens here, the plain text input is put into the box here, and encryption algorithm is applied on it. This is from the Bob side. Bob is trying to send to Alice the data. Okay, now what does Bob do is, Bob has the public keys of all the people. Okay, so public of Joy, Mike, Alice, and Ted is there. Now, Bob wants to send to Alice, right? So Bob will lock this with the public key of Alice. So it is as PU. A means Alice. Public key of Alice will be used to lock it. Okay, and none of the other keys can be used to open it. Not even Alice public key. The only key which can open this is PRA, which is private key of Alice, which only Alice has. So even if Joy gets in between the path, or if Mike also hacks in between, Ted hacks in between, they do not have the private key of Alice. Only Alice has the private key. So even if they get it, it won't be of any use to return it to Alice, right? So Alice will be getting that box finally, and Alice will be able to open it using her private key. Okay, private key. So Alice will be getting the data from it. So this is what happens in the secrecy. The data remains secret till the end, and then it got opened. Okay, so essential steps are also same, which I have explained. You can go through it. Now, public key crypto system secrecy. So the whole, if we combine together, what will happen is, from the source A, there is a message source and an encryption algorithm is applied on it. And encryption algorithm requires which key? Public key, right? We are trying to lock it using public key. So public key of Bob will be applied here. Okay, Alice or Bob, whatever you mentioned, that doesn't matter, but public key will be applied here, and that will be passed. And cryptanalyst means in between, if someone hacks, they will be able to open it only if they have the private key of Bob. Okay, and finally, if they don't have the private key of Bob, they'll not be able to open. And from here, in decryption algorithm, the requirement is private key of Bob to open it. So private key will be provided, and the destination, it will be open. Okay, the same thing is also explained here. You have to write in this way. Okay, whatever I've explained, just write it in this format. Okay, now second part is authentication. Secrecy means whatever I have sent, that it remains secret till the end. Now authentication means, consider from this point of view, whatever I have received, whether it is authentic or not, whether some useless person has given me, whether a hacker has given me it, or Bob only has given me, that verification is called as authentication. Means whatever I have received, is it authentic or not, whether someone came in between and changed the data or not. Authentication. Okay, so how do we ensure authentication here? So for authentication, whenever we are encrypting, we have to lock using private key here, private key of Bob. Okay, it is getting locked here. And then in Alice public key, Alice will be having all everyone's public key. So using the Bob's public key, it will be opened. So if she is able to open this box using the Bob's public key, the only possibility is it has been locked with the only possibility is, if Bob's public key work on this and this opens, that means it was locked using Bob's private key. If suppose Joy's private key was used to lock, in that case Bob's public key won't open it. Bob's public key getting opened means Bob's public key is able to open this lock is the proof that it was locked using Bob's private key. I hope you got it. Okay, so this is how authentication is done to ensure Bob only has sent the data. Okay, so the plain text output will be seen at the Alice end. Okay, combining these both, it will be called as authentication secrecy public key crypto system. Okay, so this is the diagram for just authentication. So if we combine both of these, we'll be having this one. Okay, public key cryptography for both authentication and confidentiality. Okay, they can ask you like that question only. Explain the public key cryptography for both authentication and confidentiality. For that, you have to write the whole answer which I have explained. If we combine both of these, we will be getting this one. Okay, so the private key of A is taken here, and the public key of A is taken here for the decryption. This is decryption part, this is encryption part. Okay, you have to make it in this. The next super repeated topic is the RSA algorithm. Okay, so using RSA algorithm, you have to perform encryption and decryption. Okay, and we have been given with 4 inputs. First, we have been given with P is equal to 5, Q is equal to 11, E is equal to 3, and M is equal to 9. What is RSA algorithm? RSA stands for Rivest Shamir Adelman, is an asymmetric public key. So these three scientists were there who discovered this algorithm. Okay, so it is an asymmetric, means public key cryptographic algorithm used for secure data transmission. It uses two keys, which is public key for encryption and private key for decryption, as discussed previously. Right? Public key is used for locking and the private key is used for unlocking. The secret on different numbers. What does this mean? See, how this algorithm works is you have to write the algorithm like this only. Select two large prime numbers P and Q. So what is P and Q? Two large prime numbers. Then multiply them and find out n. Okay, then compute the Euler's-Totten function. Euler's-Totten function. So the Euler's-Totten function is calculated p minus 1 into q minus 1. That will be the phi of n. Whatever it is, I am not sure what is phi of n. So choosing the public key exponent e such that the e lies between the 1 and phi of n. Okay, and the e value which we select, that should be equal to the means if we find out the GCD between the phi of n and e, we will be getting 1, means there is no common divisor. Like for example 7 and 20, the common divisor between 7 and 20 is just 1, like that. Okay, so that kind of e we have to select, which is uh, in between 1 and phi of n. Okay, now compute the private key component exponent d such that d is equal to E inverse mod phi of n. If you multiply E inverse and mod phi of n, we should get the answer as d. Okay, what does this mean? That I'll explain using an example. And for encryption, it will be C is equal to m power e mod n, and for decryption, it will be C power d mod n. Okay, if you see the example, it will be much more clearer. Now, four inputs have been given: P, Q, E, and M. Now, what is P? P and Q are the large prime numbers. Okay, it's not large, but who cares if it's not large. P and Q we have been given, we have to proceed with this. Okay, 5 and 11 are two prime numbers. We have to first multiply them to find out the n value. So 5 into 11 is 55. 55 and n value is we have got here. We have to find out the phi of n value also. Phi of n value will get 5 minus 1, 11 minus 1, which is P minus 1 into Q minus 1, right? So if you multiply them, we'll get 4 into 10, 40. That is phi of n value. Next, we have to compute the private key d. Okay, how do we compute the private key d? D is equal to E inverse mod 40. 40 is nothing but the n value, right? Mod n we have to put here. So whatever the n value we get, sorry, not n, q 40 will okay, phi of n, mod phi of n it is. So we'll be taking mod 40 here, and E inverse means what? E value is 3. So 3 inverse is what? 3 inverse is nothing but 1 by 3, right? So 1 by 3 if we put here, what it will become? 3, we can shift it here, right? 3 into d. So 3 into d is equal to 1 mod 40. What does this mean is we have to find out a value of d such that if we multiply it by 3, whatever answer we get, like for example we have taken 27 here, multiplied 27 with 3, we got 81. Now once you divide 81 with 40, you have to get the remainder 1. Whatever you choose here and multiply that answer, if you divide by 40, you have to get 1. So this is trial and error method. Try 3 into 1, 3 into 2, 3 into 3. So like 3 into 1 is equal to 3. Divide 3 by 40, check if remainder 1 is coming. If not, go with 3 into 2, then 3 into 3, then 3 into 5, 3 into 20, like that. 3 into 27, when you do 81, you will get, divide 81 by 40, you will be getting remainder 1. So your d value you will be getting, that is 27. Okay, next, after that encryption should be done, which is C is equal to the above formula was there, right? C is equal to m power e mod n. Okay, so n value is 55, which we have calculated here, and what was that? M power e, right? So m value is 9 here, which has been given. M is message. Okay, so 9 power e is 3, so 9 power 3 is 729 mod 55. Use a calculator and find out. You'll get the value here for the mod, which is 14. Okay, next, decryption. How you will do? M is equal to c power d mod n. Okay, c power d mod n. So c value we have got here as 14. You have to check if it is correct or not. So again we have to, when we get this answer, we have to again get the m value, which is initially taken as 9, right? So how do we do that? C value is 14, D value is 27, mod 55 we have to put. Now, even if you do it in calculator, you will not get this answer, because 14 power 27, the calculator's limit will be finished. Now, how do you solve this type of question? I'll explain how do you use modular exponentiation after this question. Okay, so there is some trick. Just assume that the trick is called trick of modular exponentiation. If you put that trick, you'll get an answer 9 here. Okay, so once you have got this answer, just verify initially also it was the same or not. That's it. Okay, that you will get the ciphertext and decrypted message. Just for writing these two things, you will be getting 10 marks. Okay, I mean the steps also carries marks, but if you write here as 15, you will lose all the marks. Okay, so accuracy is important here. Next, how do you calculate the large mod values? Like for example, 14 power 27. Calculator also can't do it. So how do you do it? Okay, so you have to simplify this. Now, for example, if the number given is 7 power 13, this also calculator cannot calculate mod 20. Now, how do you simplify this? To simplify this, 13 is present here, right? Write this in binary. 13 will be in binary 1101. Okay. Now, after you have written this in binary, what you have to do is you have here as 0, sorry, you have here as 1 2 4 8, right? This place is nothing but 2 power 0. This place is nothing but 2 power 1. This place is 2 power 2. This place is 2 power 3. I hope you know this much, right? You had studied this in third semester, right? So based on that same concept only, you have to write it here. Since this is 1, this is 2, this is 4, this is 8, you have to take 7 raised to 1, 7 raised to 2, 7 raised to 4, 7 raised to 8, and do the mod 20. Find out these 4 answers and keep. This one will be done easily by the calculator. Once you do this and keep the 4 answers you have here, 7911. What you have to do with 7911? Observe where 0 is there, ignore it. 0 is present in the second place, right? In this place 0 is present, so you have to ignore this one. Okay, now you just have been left with 7 1 and 1, right? Now what you have to do, 711 is there, just put here 711 mod 20. You'll be getting an answer which is 7. Just ignore the one which has a 0 associated in that position, and take the remaining ones, multiply and do mod 20. The answer you will get as 7. So 7 power 13 mod 20 is equivalent to 7 mod 20 itself, which is 7. Okay, so the same way you have to do it for 27 also. Write 27 in binary. Wherever is 0, first calculate 14 power 1, 14 power 2, 14 power 4, 8, like that. Do to tell how much ever it comes, and ignore the places where 0 is present, and then take the remaining answers after doing the mod 20 here and multiply them and do mod 55. What answer you get? You will get 9 here. Okay, this is how you solve RSA. Let's take another example here for better revision. Now see, the same thing, explain the RSA algorithm operation. You have to first explain the RSA algorithm. That's why read the question. If they ask algorithm and you don't explain algorithm, even if after you do all this, you'll get just 50% marks. Okay, algorithm has 50% marks, this has 50% marks. In case they don't ask about the algorithm, you can proceed with this. That will be carrying the whole 10 marks. Okay, I think it's pretty common sense. Now, 4 things have been given: P, Q, E, and M. Now what you have to do? You have to do with the same thing. P into Q you have to calculate, which will be equal to 33 here. N value is 33, and you have to find out phi of n, which is P minus 1 into Q minus 1. That is 2 into 10. It is 20. After that, you have to see E value they have given, so we need not worry about calculating GCD and all. Mostly E value they give. Okay, this is from the previous year papers only. Okay, so E value they have given. In case they don't give the E value, you can also calculate E value. You have to find out E such that it will be between these values, phi of n, which is 20. Between 1 and 20, between 1 and 20, find out a number which has the GCD 1. Okay, means suppose I take 5. If I take 5 and 20, GCD won't be 1, right? 5 and 20, the highest common divisor is 4, no, sorry, 5 only, right? So it cannot be taken. So 7 and 20 if you take, you will be getting a value, and you have to take as least value as you can. So E value will get as 7. Okay, now what you have to do, again the same thing, E inverse. So it will be 1 by 7. 7 will be taken here. Now 7D, multiply D with some value such that the remainder will be 1 when you divide by 20. Okay, so it will be something like this: 7D by 20. When you do, the remainder should be 1. Okay, so D value can be 1, 2, 3. When you go for 3, 7 3s are 21. 21 divided by 20, the remainder will be 1. So the value which you have got is 3 for D. Now apply the formula: C is equal to M power E mod n, calculate and keep the C value. For decrypting, C power D mod n, C you will put here, and D value is 3, and mod 33, so you'll get the value of 5, which you have initially taken. So therefore, after right, public key is 733, private key is Dn, which is 333, and the ciphertext C is 14, and decrypted message M is 5. Okay, it's as simple as that. Next, the second most repeated topic in the numerical section is Diffie-Hellman algorithm. Okay, first you have to explain Diffie-Hellman key exchange algorithm. Okay, here also they have asked algorithm. Don't skip this question. If they ask algorithm, write the algorithm. Okay. After that, we have to apply the key exchange for the given values. Q is 71 and alpha is equal to 7, and we have to the A's private key is given, B's private key is given, and we have to calculate A's public key, B's public key, and shared secret key. First thing, we have to go with what is the Diffie-Hellman key exchange algorithm. Okay, so Diffie-Hellman key exchange algorithm is a public key cryptographic technique used to securely establish shared secret key between two parties over insecure communication channel. So there will be a shared secret key, and they will be having private keys also. It is based on the difficulty of solving discrete logarithmic problem. This much thing you have to write. After write the algorithm, includes the first step wherein we have a large number prime, which is q, and a primitive root alpha, which is alpha of q. Okay, so two numbers will be given. In this case 71 is given and 7 is given. Okay, these two things will be given for you for sure. Now after these two things are given, what you have to do, each user selects a private key. Suppose the user A selected XA, user B selected XB. After that, public key will be generated. So the algorithm is as follows: you'll be given with Q, which is a large prime number, and its primitive root will be given, which is alpha. After that, you have to choose two private keys, which is XA, XB, and calculate the public keys, which is YA, YB. Okay, like that. Now, how do you calculate YA? Alpha power XA mod Q, and YB will be alpha power XB mod Q. After you have calculated YA and YB, shared secret key is computed as follows: K is equal to YB power XA mod Q and YA power XB mod Q. This two to three times you have to write, then only you'll understand. If you miss, like you put instead of XA you put XB here, the whole answer will be wrong. You'll lose all the marks. So be very careful what is here, and what is getting put here for the calculation of YA and YB and so on. Okay, write this and practice. Okay, even if you think you can just see it and put it in mind, in exam when you try to again remove it from mind, nothing will be getting removed. Okay, that's why I'm telling, try it in practice. Next numerical example: if they have given q value is equal to 71 and alpha value is 7, and a's private key, the value they had given, which is xa, is 5, and b's private key is also given, which is 12. Okay, these four things they will give for sure. Now the first thing is calculate the a's public key. Ya is nothing but uh, alpha power xa, alpha power xa mod of q. Okay, so once you do that, you will get the ya value. Similarly, find out the yb's value, which is alpha power xb mod 71, which is the mod q, and once you get, you will get the value of yb. Ya and yb you have got. Find out the shared secret key, which is k value. Okay, k value you can find out in any way. Either you can use this formula or you can use this formula. Both you'll get the same answer, but depict, write both of them and calculate, otherwise still you can lose marks. Okay, so you know that the value is going to be coming as same, and the examiner also knows the value is going to be coming as same. But what if you made a mistake here? If you made a mistake here, if you do both and if it doesn't come same, the mistake will be rectified there itself. But if you become too much overconfident and you don't check two times, firstly you will lose marks for not doing the second step. Second, if the answer is wrong, you lose whole marks. Okay, so take some time and do this also for verification. Okay, the same method how authentication is there in RSA, right? Like that only you have to also do authentication. Okay, now after you have done that, you will get the same answer here, which is k is equal to 30. After that, that's it. You have to just write the a's public key you have found out, b's public key you have found out, and shared secret key also you have found out. Got it? This is the same way you have to solve any type of question of Diffie-Hellman. Now, the last question in this module is explain man-in-middle attack with an example, or they can ask you how Diffie-Hellman key exchange algorithm is useful in evaluating man-in-the-middle attack concept, or they can also ask you with a neat sequence diagram, explain how Diffie-Hellman key exchange is insecure against man-in-the-middle attack. Means see, Diffie-Hellman we have learned now what it is, right? But in Diffie-Hellman, what happens? A man in the middle, comes in the middle and attacks it and hacks the system, and Diffie-Hellman can't do anything to stop it. Okay, it is a very weak algorithm, that's why. Okay, so how it happens, that we have to explain in this question, and you have to also write a neat sequence diagram. Okay, I have not included the diagram here, but the diagram is also very simple. Just if you go through this in your mind, in your imagination, the diagram will start getting created. That same thing you have to write in the exam sheet also. Okay. Now, what is man-in-the-middle attack? A man-in-the-middle attack is a security attack in which an attacker secretly intercepts, alters, or relays communication between two parties who believe they are directly communicating with each other. Okay, this sentence itself is enough for the diagram. What happens is, see, this is A, this is B, they both are communicating, but actually what's happening? There is a man in middle and man is communicating between them and exchanging the messages. You got the point, right? The messages are coming through the man and going here, but they are thinking they are texting with each other. Okay, this also can be related in real life, right? You're texting to someone and in between who is there, right? So like that only. Okay, so that is also a type of man in the middle attack. Nothing is encrypted in real world, right? So yeah, that can be an example, but that is not verified or revealed. Okay, so let's just keep it aside. Now, working of MITM attack. Okay, now two legitimate users A and B attempt to communicate securely. Okay, now they are thinking that trying to communicate securely, nothing is happening. Then the attacker comes. Okay, places himself between A and B without their knowledge. Okay, he just comes in between and they don't know someone has come in between. Attacker intercepts the messages sent by A to B and the messages sent by B to A. Whether it is A is sending to B or B is sending to A, it's not like this. What's actually happening is A is sending to M, M is reading that messages and enjoying, and it is sending to B. B is also sending the messages to M, and M is enjoying those messages and sending to M. Okay, so M is enjoying in between. Attacker may read the data, modify the data, forward altered data to the receiver. Okay, so that are the disadvantages. Now, MITM attack in key exchange. Now, how it happens in Diffie-Hellman exchange? Okay, what happens is the attacker substitutes the public keys. We have calculated the public keys YA and YB, right? So attacker will substitute it with YM and YM. Okay, so instead of Y and YB, YM will be there in the algorithm. A and B unknowingly establish shared keys with the attacker. Okay, so A and B are talking with whom? Not with each other. With the attacker, they are talking. Okay, and the attacker can decrypt, read, and re-encrypt all the messages. So attacker has all the control over it. Okay, the messages and everything. So that is a very bad scenario. Okay, so how it happens using a scenario, you have to make it, the diagram would be very simple, nothing. You have to make A and B and the M will be here, the messages are getting exchanged from here, and this is getting exchanged from here. The message which is sent from M to A is YM, and here also the public key is sent to B, it is YM. So if I explain this scenario, it will be much more clearer. The participants in this whole diagram are three, which is user A, user B, and attacker M. Step by step, user A and user B agree on the public values Q and alpha. Okay, user A sends the public key YA to user B after calculating. Attacker M intercepts YA and sends his own public key YM to user B. Okay, so YM is sent to user B. Now user B sends public key YB to user A, but attacker M intercepts YB and sends YM to user A. So the attacker has both YA and YB in jail, and M has sent the fake public key which is YM to both. Okay, now user A computes shared key with M. So user A is having a shared key with M. User B also has a shared key with M. Attacker M now has two shared keys, one with user A and user B. User A believes the key is shared with user B, and vice versa. B believes that it is shared with A, but M M is able to decrypt the messages from A, read, modify them, re-encrypt them to B, and vice versa. It is able to do it from the B side also. Okay, so this is what you need to explain the man in the middle attack. Moving on to module 3, we have the first question, which is explain the public key authority and public key certificate techniques for distribution of public keys. Okay, so now we have understood that public keys are accessible by everyone. Okay, everyone should have it. Okay, but not everyone means like not hackers also should not get the public key. Okay, like that, the only persons who actually need the public key, they are involved in the transactions, those people only should get the keys. So now to for everyone to get the key, we have to distribute the key, right? So there are few techniques in which we can use those techniques to distribute those keys. So the two techniques which they have asked is public key authority technique, and second is public key certificate technique. So let's understand what each of this is. Public key authority. Okay, stronger security for public key distribution can be achieved by providing tighter control over distribution of public keys from the directory. So there will be a directory where the public keys will be there. If we make it more secure, a little bit more secure in between, so that it is we are making it tighter control. Okay, providing tighter control over the distribution of public keys to make it more secure. Okay, it requires users to know the public key for directory and that they interact with the directory in real time to obtain any desired public key securely. Okay, so totally 7 messages are required. So what happens here is, this is the diagram which you need to make. Okay, so since they have asked the diagram, okay, with the need diagram explain the following. So you have to make this diagram. No, it's very simple diagram, it's not very hard. So what's actually happening here is, see, a and B are here. Okay, so A and B want to talk to each other. Okay, but they don't have each other's public key, and the public keys are present in public key authority. Okay, now what does A do is, A will request for the public key of B. Okay, I'll repeat. A will request for the public key of B at time 1. Okay, so that's the first step. Second step is, the public key authority will reply with an encrypted message of, which will include private key of authentication, means authority. Private key of authority will be encrypted and it will be locked with that, and it will have the information which is public key of B and the request which was sent and at the time t1. Okay, so why these all things are there is, firstly, why is encryption is there? Because someone in middle can take the public key of B, it has to be secure. Second, why is private key of authentication included here? Private key of authentication is included to lock it, to encrypt it. To encrypt we need a private key, so that private key of authority is used here to encrypt it. And what is the messages we have? This is the answer which A had requested, public key of B, and request and time is also sent to A. Why? Because it is to ensure that the same request which has been come, that only has been sent to A. Otherwise there is a possibility that request could have been altered and then sent to this, right? So it is sending back the request for A to check if that only the request was sent by A or not. And time is also sent to ensure that whether it was not the previous key or previous request which is getting answered now, which time which request was there, that answer is present here, and locked with a private key of authority. Now A will have a public key of authority, so A will be able to unlock it and get this information and check using this. So A will finally get the public key of B. Okay, after A gets the public key of B, A can communicate with B. What A will do, A will use the public key of B to encrypt the message, and it sends a IDA and N1. IDA is nothing but identification of A, and N1 is nonce 1. Okay, nonce means a unique transaction ID. Like for example, when you do the online transactions, you'll be getting a transaction ID, right? So that transaction ID is N1, it's sending to B. Now B wants to reply back to A, but B does not have the public key of A. So what does B do? B does the same thing which A had done, which means request at time 2, and public key authority will be sending an encrypted message of PR with the private key of authority locked. The answer in the message which should be included in that is public key of A with the requested time and the request which was sent. These things will be sent to the responder B. Responder B will be able to unlock it because responder B has the public key of authority. Okay, so private key will be unlocked with the public key of authority. It will get the message and it will again do the same thing, reply for whatever the nonce was sent by A. That reply will be sent by B, and N1 will be sent and N2 will be sent. Okay, N2 is for ensuring that B has sent, and N1 is for ensuring that it is come from A to B successfully. So public key of A is used to encrypt it and send to A, and A will be then sending back the public key of, sending back N2, saying that I have received N2 successfully. We can communicate now with the public key of B. Okay, to encrypt it uses public key of B, and it sends to B. So this is how the public key is exchanged, and A and B both have the public key with a secure method. Okay, that same thing whatever I explained, the 7 steps is mentioned here. You have to write it in this way. After, if you have understood, if you go through this once, you'll understand this. You have to write it in this way only. Okay, next. The second way of exchanging or giving or distributing the public keys is public key certificates. Okay, certificate means what? There will be a paper in which someone's name will be written, which will be saying that this person is authentic, the person is genuine, efficient, like that. Okay, so a user, what happens is, whoever wants to get registered as a public key certificate, means certified user, what they will do is, a user must appeal to the authority for a public key for every other user that it wishes to contact. So if A wants to contact to B, C and D, A will request to the authority to give a certificate which will ensure that A can contact to B, C and D, and it is also vulnerable to tampering too. Okay, means the request which will be being sent from A to authority, in between tampering can happen. Public key certificates are used to exchange keys without contacting a public key authority. So directly, without contacting to the authority, because in between something can happen, without contacting to them, how can we get the certification? A certificate binds an identity to a public key with all its content signed by a trusted public key or certificate authority. So instead of going to the public key certificate authority, we are getting it signed by a trusted public key itself. Okay, or a certificate authority itself. It's not the public key authority, it is the certificates authority itself. So if a certificate is there, that means you are authorized. This can be verified by anyone who knows a public key authority's public key. So using a public keys authority, I mean using a public key of public key authority, they can verify if the certificate is genuine or not, and everyone has the public key for public key authority, as you have seen in the previous case, right? A and B both had the public key for public key authority. A participant can also convey key information to another by transmitting its certificate. So, an information can also be transmitted if it is certified. Okay. Other participants can verify if the certificate was created by the authority. We can place the following requirements on the scheme. Any participant can read a certificate to determine the name and the public key of the certificate's owner. The information is public. Any participant can verify, that is also possible. Only the certificate authority can create and update certificates. Only the authority has that permission, and any participant can verify the currency of the certificate. So everyone can verify, but who can create an update? Only the certificate authority. So it is a secure method. Okay. One scheme has become universally accepted for formatting public key certificate is X.509. This is also very important one. Okay, so the X.509 certificate is used in most of the networks. Means in real life, we will be using this certificate to ensure that whatever the messages we are sending to our friend, that is not being read by the network providers. Okay, for that we will be having the certificates which will ensure it is secure transaction, means communication. Okay, so this is the diagram you have to make. The certificate of A will be sent to B so that B knows it's a certified user, and B will also send the certificate to A so that A will also know B is a certified user. And how do each of these get the certificates? Firstly, A will be accessing the certificate authority, not the public key authority. Certificate authority A will be accessing using the public key of A, and certificate authority will be checking it, and they will be sending back, locking it using the private key of the authority with the time t1 IDA and the public key of A. All of these combined is nothing but the certificate of A. Same thing happens at the B side also. B will also be getting a certificate, and they will exchange the certificates, and they will be sure that they are talking with each other. No one is in between. Okay, no hacker is in between, like that. Okay, so that are the two ways. The first one is public key distribution using authority. Second is using certificates. Okay. Now, next question is, listen and explain the four general categories of skills for distribution of public keys. Actually, there are four. Okay. We have just discussed the last two ones. Okay, which are the complicated ones. Separate question can also be asked. Okay, or they can ask you all the first, in which case you have not explained that much depth. Little bit briefly you can explain. Okay. Now, distribution of public keys. Actually, there are four methods. First one is public announcement. Second is publicly available directory. By the name itself, you can understand public announcement of the public keys means A will be announcing all the public keys to everyone, and B will be announcing all the public keys to everyone, and everyone can take whichever keys they want. Hacker can also take and hack. Okay, so that is a useless method. Second method is publicly available directory. That means no one will be announcing anything, but there will be a directory which is publicly accessible. But this is also not secure because hackers can also access this. Okay, it's as simple as that. You have to just explain that one. The next two have been explained in the previous question as discussed. The public key authority So whatever has been discussed, you have to include there here also, but in a little shorter way. Okay, because 4 things have been asked, you have to explain it in a shorter way. If 2 things have been asked in specific, you have to explain in detail. Okay, next. Explain secret key distribution with confidentiality and authentication, or they can also ask symmetric key distribution using asymmetric encryption. Both of these questions has the same answer. Okay, now firstly, to understand what is the secret key distribution, why we need asymmetric encryption, and why do we need confidentiality and authentication. For that, the first part of the question means the first part of the answer is just for explanation why simple key secret key distribution will not work and what is the solution for that. Okay, so if you want to understand this, you have to first understand this. Okay, but in exam you just have to write this. Got the point? To understand this, which is the final answer, actual answer, you need to understand the behind the scenes. What is a simple secret key distribution, after which you can understand this. Okay, if you directly want to go to this and by heart this, if you have that much memory power, go for it. Okay, I don't recommend it, and that is even risky. Okay, so first understand this, and if you understand, you'll be easily able to write it in your own words. Okay, that is the best approach. Now, what is symmetric key distribution using asymmetric encryption? Okay, now see, once the public keys have been distributed or have become accessible, secure communication that thwarts eavesdropping, tampering, or both is possible. Everyone has the public key, even hacker can have the public key, so we need a private key now. Now, how do we distribute the private key? Because everyone should have their own private key also, right? Public key encryption provides for the distribution of secret keys to be used for conventional encryption. Now, the basic method would be A generates public-private key pair. See, A will generate a pair which has its own private public key and a private key. Okay, and transmits a message to B consisting of a public key of A and an identifier of A IDA. Okay, so what does A send to B? A sends its own public key as well as the identification of A. Okay, and B generates a secret key KS and transmits it to A. After seeing A has sent it, because A's public key and identification is sent, B will think that yes, A has sent the proper one. A only has sent, and it will send back the KS, which is a secret key, to A. Okay, B will be having the secret key, it will send to A. Now, after A has the secret key, whenever a message comes from A with the secret key, B will know that it is coming from A because B has only shared to A the secret key. If C also sends a secret key to, if C sends with KS to B, B will not know it has come from C because KS is a proof that only from A it can come. So if a hacker has hacked it and got the KS from A and sends KS to B, B will think it's coming from A and B will be talking to a hacker. Okay, like a stupid, he will be talking to a hacker. So that is the disadvantage of simple secret key distribution. A third party can intercept the messages and then either rely intercepted message or substitute another message, such as attack is called man in the middle attack, which we are discussing in the previous module. Okay, those things can happen. That's why only we want to have a secure exchange of secret key. Okay, so secret key distribution with confidentiality and authentication, these two things are required. For that, what happens? See, A is the initiator. A will be sending an encrypted message with the public key of B and a nonce 1 n1 and a identification of A. B will be getting that. Next, B, what it will be doing, it will send its own nonce with a public key of A encrypted using this to A. Now A will know that since it is encrypted, also N1 has come and N2 has come, it is from B. Then only A will be sending back the N2 to B to say that I have received the message and I have again encrypted and sent back to you. Then only after this much things has been done, then only A will send the actual KS to B. Okay, in this case, KS is coming from A. So those things don't matter. What matters is it is secure or not. So exchange of nonce happens here. That is only secret key distribution with confidentiality and authentication. Okay, the same thing is given here. Go through it once and um, write it in the exam in the same way. Okay, hybrid scheme is also there. It is underway where we will be having keys distribution center. This is nothing but the public key authority will be there. We'll be requesting to the authority to give the public keys. Okay, the first question we have discussed, that is another method. Okay, this is optional. This is not mandatory to write in the exam, but the above points are mandatory. Okay, the above points from here. Okay, next, explain the use of control vector encryption and decryption for controlling key usage. Now, see, keys are sent to everyone. Everyone has their own keys they can use. Okay, but if someone is trying to use it more than what is required, that would be suspicious, because there are people who could be a spy, right? They could be acting as they are in the team of the our team, but they are from the opposite person's team, hackers team. So if they are trying to use it more than what is required, that would be a key point that they might be a hacker. So we have to control the usage. How much ever is required, that much only we have to give. That is the best security, right? So for that will be using a control vector. Okay, what is a control vector? It defines a set of bits that is permitted operations for a key. For example, if this key is there, what all this key can do? If you give unlimited access to whatever you can do, how much ever you can do, hackers also can come in our team and hack this. So it may specify which type of algorithm you can use. What are the allowed operations? Whether you can encrypt with the key or decrypt with the key. What are the key usage constraints? How much you can use? What is the mode of operation? So to encrypt it, the control vector is first processed using hashing function, and the output of the hash is XORed with the master key, and then a session key is encrypted using the derived key. Then the output is encrypted session key bound to the control vector. These four steps are there for encryption. The reverse of this is in the decryption. And if successfully decrypt, that means the only if it will be the decryption will be successful only if the correct control vector is used. Okay, so control vector ensures that the usage is proper. Whatever is assigned to it, the key, that only it is being used for and within the limit. Okay, so that's the same role, and the diagram is given. You can go through it. Control vector, master key, session key, all of these combined. Control key, control vector and master key together XORed, and that will be the input to the encryption function along with the session keys input, and that will be the encrypted session key. The reverse of it, that will be the decryption. Okay, and advantages also here. This is optional, you can just go through it once. Okay, next, explain X.509 certificate format. Okay, now X.509 certificate format we have discussed in the types of certificate question. So in certificates here, this one is universally accepted certificate for the public key and the private key exchanges. Okay, so the this there will be a specific format which will be having the following parameters. Okay, V, S, N, A, L, C, A, U, C, A. So all of these parameters combined, the whole information will be there. A certification will be there for one unique user. Okay, so there are different types of certificate: forward certificate, reverse certificates. They can ask you what is forward and what is reverse also. Forward certificates, certificates of X generated by other CS, and reverse certificates are certificates generated by X that are certificates of other CS. Okay, a slight difference, but it is different. And an example is also given here. You can just go through it once. And certificate revocation will also happen. Certificate will not be valid forever. There will be an expiry date. After that, it will not be valid anymore. Why it will be why there will be an expiry? Because user's private key is assumed to be compromised. If it is for a long time user has not used, there will be a possibility that it is compromised, so it will not be valid anymore. Again, it has to re-register. The user is no longer certified by the CA. Reasons for this include that the subject name has changed, certificate is superseded, or certificate was not issued in conformance with the CA policies. If some policy was not satisfied, it will not be valid anymore, that certificate. So the CA certificate is assumed to be compromised. Okay, the certificate itself also can be compromised, so that can also be a problem. But the question which has been asked for us is explain the X.509 certificate format. If anything apart from the format has been asked, you can write these points here. Okay. Now, since the format has been asked, you have to make this diagram here, wherein the first thing will be the version, second will be the certificate serial number, and then we have the algorithm identifier, the period of validity till when it will be valid, what is the subject keys public info, okay, and the issuer's identifier, subject identifier, and finally we'll have extensions before the signature. Okay, and this is the revocation list, which all certificates has to be revoked, and the information regarding that, which is the issuer name, the updated date, next updated, and so on. Okay, means till when it will be valid. Now, the meaning of each of these, the details are given here. Version is nothing but the different when it was released, which time period, that time period will be defined by the version. And serial number, it is a unique integer value within the issuing CA that is unambiguously associated with the certificate, a unique thing to identify a certificate. And signature algorithm identifier, whether the signature is valid or not, to identify that an algorithm is present. Issuer name, who has issued the certificate, till when it is valid, period of validity. Subject name, to whom it is assigned, to which user. Subject public key information, the subject who has means to which user it has been assigned their information. Okay, their public key information will also be present. and issuer unique identifier and subject unique identifier. Who has issued their identifier and who is the subject their identifier. Extensions, a set of one or more extension fields were added in the version 3. Okay, so a little bit more things will be there. And signature, which covers all the other fields of the certificate. Now the format which was there earlier in this question, VS, and what all these things mean. Okay, so Y of X means certificate of user X. X will is the user, the certificate authority is Y, like that. Okay, and YI means the signing of I by Y. Okay, the signing of I by Y, which is in I is consists an encrypted hash code appended. Now, V is the version of the certificate, SN is the serial number, AL is the algorithm used, CA is the certificate authority, UCA is the unique name of the certificate authority, CAA is the name of the user, UA is optional unique identifier for the user A, AP is public key of user A, and TA is the period of validity. Okay, once you have gone through this, you will be easily able to see V is version, SN is the serial number, AL is algorithm, CA is certificate authority, this is unique identifier, this is the username, and this is the optional user identifier, and this is the public key, and this is the time period. Okay, period of validity for the certificate. This was things you have to write. Okay, next, explain the PKIX architecture model. What is PKIX? Public key infrastructure. Okay, means this infrastructure will have all the information related to the public keys and the certificates. So there are some operations also happening in between, like what is end entity, what is registration authority, certificate authority, CRL issuer, certificate authority, and how they are connected with each other. Okay, so what is end identity? The end user or the devices like server, router, or any other entity that can be identified in the subject field of a public key certificate. Who all are participating in this process? Those are called as end identity. Second is certification authority, who is giving the certificate, the issuer of the certificate. Okay, and registration authority, who is registering those certificates. CRL issuer, an optional component of that a CA can delegate to publish the CRLs. Repository, a generic term used to denote any method for storing the certificates, and CRL so that they can be retrieved by the end entities. And for managing each of these, we have some functions. The first one is the registration function. It begins by enrolling a PKI, which is public key infrastructure, involves some offline or online procedure, and entities issued one or more shared secret keys for subsequent authentication. Okay, next is initialization. We are initializing the keys and keeping for it to be used. Certification, it will be certified whether it can be used or not. And then we have the public pair key pair recovery. Key pairs can be used to support digital signature creation and verification, encryption and decryption or both. So there will be pairs of keys for performing different kinds of operations. Okay, so those will be stored in the backup. Next, key pair update. If you want to update it or replace with a new key pair, we can do that. Revocation request, if any certificate is abnormal or it has been expired, we will be requesting for a revocation of it. And cross certification, will be certifying CA with another CA, and they will be cross verifying each other. Okay, means validating the validity of each other. Okay, and for that we have some protocols. First one is certificate management protocol to manage all the things which are related to certificates, and certificate management messages over CMS to send and receive the messages, whatever is the information to be exchanged between the certificates, that is done by this protocol. Okay. Moving on to the module 4, we have the first question, which is about the PGP protocol. Okay, you have to explain confidentiality authentication services provided by the PGP protocol. So we'll be seeing two things here. First one is authentication. Okay, how the authentication happens is a message comes from here. Okay, from the sender side, a message comes from here, and that is going to be hashed. Okay, so the first thing is the sender creates a message, and SHA-1 is used to generate 160-bit hash code of the message. Okay, so that is the thing here, and then it goes to the encryption here, and it is encrypted using a private key of A. Okay, the hash code is encrypted with RSA using the sender's private key, and the receiver uses RSA with the sender's public key to decrypt and recover the hash code, which is here. Okay, so the recovery is happening here, and it creates its own hash code and the hash code which is we have received. Okay, and these two will be compared. If both are same, means nothing has been happened here, and that is authentic message, like that it will be concluded. Okay, whereas confidentiality means it is provided by encrypting messages to be transmitted or stored as locally as files. Okay, so firstly what happens, the sender generates a message and a random 128 bit to be used as a session key. For each session there will be a key. Okay, that will be lasting for a period of time. So sender has taken a message, it will be taken to Z. Z is nothing but the message is encrypted using cast 128 or IDEA or 3DES with a session key. Okay, session key is generated and the cast 128 encryption happens. Okay, that happens here, and from there the session key also takes the encryption here. Okay, session key is encrypted with RSA using the recipient's public key. After that, and prepended to the message, the receiver uses RSA with its private key to decrypt and recover the session key. After those things happen, the public key, encryption, all the things, and after those things, the decryption happens here from the public key. Okay, the receiver uses RSA with its private key. Okay, its own private key it uses to decrypt the message. Okay, after that the session key is used to decrypt the message. Two decryption happens. First one is the RSA with its private key, and second is the session key to decrypt the message. Okay, finally we'll be reaching here and the message will be received here. So instead of using RSA, also Diffie-Hellman can be used. Diffie-Hellman is a key exchange algorithm. In fact, PGP uses a variant of Diffie-Hellman that does not provide encryption decryption known as LCaml. Okay, but that is out of the scope of the syllabus. Okay, so it was there in previous scheme, but in this scheme it's not there. Okay, now confidentiality and authentication. Here both the services may be used for the same message if we combine both. Okay, because the question which they had asked is combination of confidentiality and authentication. So we are just combining both of these. First, a signature is generated for the plain text message and prepended to the message. Then the plain text message plus the signature is encrypted using cast 128, and then a session key is encrypted using RSA. Okay, two encryption happens. First one is cast 128, second one is session key encryption. Okay, so if you take both of those diagrams here, confidentiality and authentication, and finally it will be compared here. Okay. So this is the thing you need to make. Next one is how PGP can be used for exchange of messages. Okay, so PGP means pretty good privacy. Okay, it is a cryptographic system used to provide secure email communication. It combines public key cryptography, symmetric key cryptography, and hash functions. Three things it combines: public key cryptography, symmetric key cryptography, and hash functions to ensure confidentiality, integrity, authentication, and non-repudiation of messages. Okay, so how the process happens? How does PGP work? To make in the exchange of messages, how does PGP help us? First one, message creation. The sender prepares a plain text message to be sent to the receiver. Second, hashing happens, which ensures integrity. A hash value of the message is generated using secure hash algorithm. Whatever the message is there, for that algorithm will be applied and a hash value will be generated. Okay, it will be unique to that message. Hash ensures message integrity. Okay, after that, digital signature, which is authentication. Hash is encrypted using the sender's private key. So after that, inside the hash, private key also gets involved. Then encrypted hash forms the digital signature. Whatever is the output of that after that involvement, that is called as digital signature. This signature is attached to the message itself. Along with the message, the signature is also attached. Now compression. The message and digital signature are compressed to reduce the size and improve security. After that, a session key is generated for the transfer of the message. Message is encrypted using the session key, and the receiver's public key is also used to encrypt. Two encryptions happen, then the transmission happens. Okay, and once it gets received to the receiver, all the things which happened in the encryption, the reverse of those things happen one by one in the receiver side, and a hash is also generated based on the values which are there. If both the hashes match, the generated hash value and the received hash value, that means the message has not been compromised and the authentication is verified. Okay, so security services provided by PGP: confidentiality, integrity, authentication, and non-repudiation. Sender cannot deny sending the message like that. Okay, and advantages are given here. You can go through it. Okay. Next is explain the suitable diagram overview of Kerberos. Okay, what is Kerberos? Kerberos is nothing but a service. Okay, it provides session keys and it provides authentication, those kind of things. Okay, so the first step is user logs onto the workstation and requests services on the host. User has logged in and he requires a service on the host. Okay, so first step is requesting a granting ticket for that service. It goes to the authentication server, and from the database the server's information is taken and kept here. Okay, after that, the ticket plus the session key is sent back to the user. Now if the user wants request servicing granting ticket, it goes to the ticket granting service. Okay, if some specific thing needs to be done, so that ticket along with the session key is returned back to the user. Okay, and once per login session, so this whole thing happens in one login. This happens in one login. Okay, once per type of service. Okay, and if the user wants to request a service such as password or password to decrypt the incoming messages, then it goes to the server. Okay, Kerberos server it goes, and from here it provides the server authentication details. Okay, so these things happen in the Kerberos. Okay, the same thing is here. The components in the diagram, what all are there? The client, authentication service server, ticket granting server, application server, Kerberos database. Okay, and step-by-step explanation is also given here for your reference. Whatever I explain, the same thing happens step by step. You can go through it. Okay, in exam also you have to write it in this way, in point by point. Okay, and there are some key features which are single sign-on. With single sign-on, both the things happen. See, if we see the diagram here, within the single sign-on, both of these things happen. The request and the response both come in the single login. Okay, once per login session. Okay, so those things are there, and no password transmission, you need not enter the password twice, and mutual authentication is present, both the client and server verify each other, and timestamp based security is present. Okay, that is how Kerberos works. Now there are two types of Kerberos. First one is version 4 and second one is version 5. Version 4 message exchanges happen. There are four logical message exchanges between the client and server. Okay, so four types of message types are there. The first type is from client to the authentication server. What it will be? To request a ticket granting ticket. Okay, means for doing something, and the message contents will include the client ID, TGS ID, and timestamp. Okay, explanation is the client requests authentication from the AS. No password is sent and occurs once per user login session. So it is used for granting the ticket. Okay, the client requests the granting of ticket from the authentication server. Second, authentication server replies back to the client with a TGT, the ticket which was requested, and a session key. Okay, so the message contains session key and the TGT. Okay, and encryption also happens using the key derived from the user's password. And AS verifies the client first, and if the client is verified, the client decrypts the message using the password after AS has sent the reply back and the client has received. After that, the decryption happens, enables further requests without re-entering the password. Okay, third type of message from the client to TGT. Okay, requesting to access a specific service. Okay, like checking the mail. Okay, so TGT will be the message content will include the TGT value, and authenticator like the client ID and timestamp will be there, and requested service ID will be there. Explanation is client proves identity using the authenticator and occurs once per type of service. Okay, and the fourth type of message is ticket granting server to the client. So the TGT again replies back to the client with a service ticket and a session key also. Okay, session key always comes because within a time period that much only it should be valid. After that, a new session should be generated for security purposes. Okay, so the same thing happens. This is a summary table. Four types of request and response are there: client to AS, AS to client, client to TGS, TGS to client. Okay, request, provide, provide means response, request, provide, provide means response. Okay, so these are the four types of logical message exchanges in Kerberos version 4. Like that, this version 5 also, it's a slightly different one. There are 6 message exchanges happening here, which is divided into 3 phases. Okay, first phase is authentication service exchange. Okay, means from client to authentication server, request goes to request a ticket. That's the same thing as the previous one, and requested lifetime is a new thing here. So along with the message contents also requested lifetime is added here. Okay, the client requests authentication without sending password over the network. Second, the AAS replies back to the client, provides the TGT and session key. Okay, so session key and TGT is provided. Now encryption happens using a key derived from the user's password. Okay, explanation is AS verifies the client and sends the credential needed to access TGS. After that, second phase, TGS. So client requests service ticket from the TGS, and that includes TGT, authenticator, and requested service ID. Okay, and the authenticator proves the client's identity and freshness of the request. After that, TGS replies back to the client, providing the service ticket. Encryption happens, encrypted using the client TGS session key. The explanation is TGS verifies the request and issues a ticket for the requested service. Okay, now TGS has replied back to the client. That's the phase 2. Third phase is client server authentication exchange. Means client is talking directly with the application server now to request access to our service. Okay, so service ticket and the authenticator will be the message content. Client proves its identity to the application server. Okay, and the sixth one, which is the last one, is the mutual authentication. Both know each other now. That is optional. Application server tries to know the client. Okay, timestamp is incremented by 1. Confirm the server's identity to the client. Okay, so here 6 type of messages are there, from client to AS, AS to client, client to TGS, TGS to client, client to server, server to client. Okay, and the purpose is also given here, can go through it. Next, bring out the technical differences between version 4 and version 5 of Kerberos, and also mention the technical deficiencies in Kerberos version 4 protocols. So version 5 is a better one, and what is the differences between these two, and what are the disadvantages which were there in version 4 that we have to discuss. Okay, so the first one is environmental shortcomings. Encryption system dependence. Version 4 requires the use of DES. Okay, DES algorithm it uses exports restriction on DES as well as doubts about the strength of DES were of concern. Means DES is not that good algorithm, and that was concerned. So that was a big concern. So in version 5, ciphertext is attacked with the encryption type identifier, so that any encryption technique might be used, it won't just get fixed to DES. Okay, a better than DS can also be used in version 5. That's one advantage. Second difference, internet protocol dependence. Version 4 requires the use of internet protocol, whereas the version 5 addresses the tag with the type and length, allowing any network address type to be used, not just internet protocol. Third one, message byte ordering. In version 4, the sender of message employs a byte ordering of its own choosing and tags messages to indicate least significant byte in the lowest address and most significant byte in the lowest address. This technique works but does not follow the established convention. The convention is all message structures are defined by the abstract syntax notation, which is the and also the basic encoding rules. These two rules are having an unambiguous byte ordering. Means we will be sure of what is the order of the bytes. Okay, so that is present in version 5, which was absent in version 4. Fourth is ticket lifetime. Lifetime values in the version 4 are encoded in 8-bit quantity in units of 5 minutes. Thus, the maximum lifetime can be 1280 minutes. Okay, a little over 21 hours. This may be inadequate from some applications. In version 5, there is extended lifetime. Okay, arbitrary we can set whatever is the start and end time. Okay, that's an advantage. Next is authentication forwarding. Version 4 does not allow credential issued to one client to be forwarded to some other host, but version 5 provides this capability. Okay, and sixth one is inter-realm authentication. In version 4, interoperability between n realms requires order of n square Kerberos to Kerberos relationship, but in version 5 it supports a method that requires fewer relationships, so it is more easier to establish a interoperability relationship between two Kerberos. Okay, now coming to technical deficiencies, double encryption. The tickets which were there in the version 4, those required double encryption. Okay, the second encryption is not necessary and computationally wasteful, so it was overcome in version 5, where only a single encryption happens. PCBC encryption. Encryption in version 4 makes use of non-standard mode of DES, that is not safe. Okay, attacks can happen there. So in version 5, explicitly integrity mechanisms and checksum hash code is attached to the message prior to encryption using CBC. Okay, so that is more secure. Session keys. Each session includes a session key that is used by the client to encrypt the authenticator, but in version 5 it is possible for a client and the server to negotiate a sub session key which is to be used only for that one connection. Okay, it is not generic, it will be just used for one connection and it will be more efficient. Okay, password attacks. Both versions are vulnerable to password attack, but version 4 is more than version 5. Okay, more vulnerable than version 5. Why? Because version 5 provides a mechanism known as pre-authentication, which should make the password attacks more difficult, but it does not prevent them. Okay, means the version 5 there are less chances for someone to attack. Okay, if there is version 4 and 5, it is more easier to hack version 4 than version 5. Okay, so these are the 4 technical deficiencies. Now, what is S/MIME? Explain the functions provided by it. S/MIME means Security Multipurpose Internet Mail Extension. Using when we send the email, we'll be making it more secure. How do we make it more secure? It is similar to PGP. Okay, pretty good privacy, but both offer the ability to sign in or encrypt the messages. In SMIME, the security is based on the RSA data. Okay, and it provides the following cryptographic securities: authentication, message integrity, non-repudiation of origin using the digital signatures, and data confidentiality using the encryption. Okay, and coming to its functionality, the functionality is very similar to PGP, what we have discussed in the first question, but in functionality of S/MIME, the following functions are present. Envelope data. Okay, it consists of encrypted content. Signed data, a digital signature is always present within the message, and clear signed data. As with the signed data, digital signature content is formed. However, in this case, only digital signature is encoded using base 64. Okay, so there is a clear signed data. Next is signed and envelope data. Signed only and encrypted only entities may be nested, so that encrypted data may be signed and the signed data or the clear signed data may be encrypted. So both the possibilities are here. Okay, so that is the functionality of s/mime to make the message more secure. Okay. Now, describe the various header files defined in MIME. There are 5 header files. Okay. First one is the version of the MIME. Second is the content type, what kind of content you are transferring. So we'll be discussing about content type and as well as transfer encoding. What kind of algorithm you are using to transfer the data. Okay. And content ID for each MIME, there will be a unique a content ID identifying a particular part of the message. Okay. And the description of that message will be present. Okay. Now, discuss MIME content type and transfer encoding specifications. We are going to discuss about content type and content transfer encoding specifications. Now, the content type just means that what all different types of data can be sent. Okay, and there are some rules, like for example, the content type header includes a parameter called boundary that defines delimiter between body parts. If you want to separate two body parts, you'll be putting twice enter, right, to ensure that this is separate, this is separate. Like that only some other delimiters are present here, which defines as a boundary. Each boundary starts on a new line and consists of two hyphens followed by the boundary value. This is the syntax. Okay, and final boundary, which indicates the end of the last part, also has two suffix. Also has suffix of two hyphens. Within each part, there may be an optional ordinary MIME header. Okay, so if you see this, this is a simple boundary. This is a simple boundary. There is two hyphen and simple boundary is written here. Okay, it's as simple as that. And which are the content types? It can be a text data, it can be multi-part data, it can be a message data, image, audio, video, or application data. All of these are accepted in MIME. Okay. Now coming to MIME transfer encoding, whether it's a 6-bit value, 7-bit value, 8-bit value, or binary value, in which format the message is going to be getting transferred. Okay, it's just about that. Okay, you can go through it. It is a little bit technical, so I'm not going through it actually. Okay, two actual encoding schemes defined are coded printable and base 64. Okay, two schemes are defined to provide a choice between transfer technique that is essentially human readable and safe for all types of data in a way that is reasonably compact. Okay, so you can either have the normal letters which we read, or it can be base 64, which means binary. Okay, base 64 also known as radix 64 encoding, common used for encoding arbitrary binary data. Okay, so base 64 can be used as well as ASCII characters, which is just normal English. Both can be used. Okay, so there are different encoding, which is 7-bit encoding. These are the data which are represented by short lines of ASCII characters. 8-bit data are short, but there may be non-ASCII characters. Binary data, it is there, but it is not human readable. Okay, quoted printable data, that is also a different type of data. Similarly, we have the base 64, which includes 6-bit blocks of input to 8-bit blocks of output. Okay, in between those length, X token is also present here, which is a named non-standard encoding. Okay. Moving on to module 5, we have the topics which are related to the IP security. Okay, so some concepts are there which you need to know. Okay, it's not that hard. Let's get started. The first one is depict and explain IP security architecture. Okay, so the first thing you have to make is this diagram, because they have asked to depict it. Okay, so this diagram you will be making, and this has mainly 4 components. Okay, first one is SPD, which is security policy database. Okay, all the data will be present here related to the policies and what are the packets coming, what are the policies applied, all those things will be present. Okay, and IKE is internet key exchange version 2. Okay, here also it will be there. So key exchange will happen here, and here it is security association database. Okay, this is the third thing. Fourth thing is IP security version 3, that is present over here. So the same thing, same diagram here also, and in between you will be writing key exchange for the internet key exchange, and IKE security association in between them, and IPSec SA pair between these two, and finally we have ESP protects data. Okay, now, you have to, in the theory part, first you have to write what is the overview of IP security architecture. IP security stands for Internet Protocol Security. Is a network layer security framework used to provide confidentiality, integrity, authentication, and replay protection. Okay, it secures IP packets as they travel between two communicating agents. This is agent 1, this is agent 2. Between them, when that packet is traveling, it will be providing the security. Okay, IPsec will be acting as security on top of it. In the diagram, both sides have same components working in harmony. Okay, the first component is security policy database. Think of SPD as a rule book. What are the rules present, that will be present there. Okay, it defines which traffic should be protected and how. Okay, whenever a packet is going out of the database or coming into the database, it will be checking if it is a protected or not. If it is not protected, how to protect it. Okay. For each outgoing or incoming packet, SPD decides whether it is to be discarded or it is to be allowed without protection or it is to be protected using IP security. Okay, so we have to choose between these three. Examples: use ESP for traffic to a specific IP, use encryption plus authentication, which algorithms to use. These are the rules present. Okay, these are the questions asked and the policies applied for each packet when it is coming. Okay, for each packet. Okay, SPT does not store keys, only policies. It has only policies. Okay, you have to make sure that you write only policies. Okay, next. IKEv2, Internet Key Exchange version 2. It is a diplomat between two systems. Okay, like this is one system, this is one system. Who is communicating on behalf of these systems is IKE. Okay, now it performs key exchange, authenticates both peers, and establishes a secure channel called Security Association (SA). Okay, two main tasks is to establish an IKE and negotiate IP security SAS. Okay, this happens before any actual data is sent. Firstly, the communication channel should be made as secure and authentic, right? Then only the data can be transferred. So IKE does that. IKE Security Association IKE-SA it is the first secure bond created by IKEv2. It protects the IKE messages only and used to safely negotiate IP security SAS. Okay, it ensures secure key exchange, protection from man-in-the-middle attacks. Okay, now IPSec Security Association pair means two things will be there. One is for sending, one is for receiving. Okay, IP security works with unidirectional SAS. That's what the diagram shows. IPsec SA pair. Each SA contains encryption algorithm, authentication algorithm, keys, and sequence numbers. Okay, and we have security association database. This is the keeper of secrets. What are the policies present? All will be stored in the database. It stores active IPsec SAs, contains keys, algorithms, SPI, which is security parameter index, and lifetime of SA till when that policy is valid. Okay, when a packet is arrived, SA is used to identify the correct SA, decrypt, and verify integrity. Okay, now next one is the IPsec ESP. Okay, ESP is encapsulating security payload. This is where protection truly happens. Encrypts the data and authenticates the data and protects against replay attacks. Till now, we have just seen what are the rules going to be applied, what is going to be checked, but who is going to actually protect and apply the protection? ESP, encapsulating security payload. Okay, ESP uses SA stored in SAD to apply that protection. Okay, so SAD will be saying which policy to apply, and ESP will be using that policy to apply. Okay, next. Flow of protection, flow of operation. Okay, packet arrives, SPD is checked. It should be checking if it is protected or not. If it is not protected, IKEv2 negotiates the keys. If SAS don't exist, then IPsec SAS stored in a SAD and an ESP encrypts and authenticates the data. Secure packet is transmitted and receiver uses SAD to decrypt and verify. Okay, so this the flow of operations happening in the IPsec architecture. Okay, next is what are IP security benefits, applications, and IP services. Applications of IP security: it is used over LANs, private public WANs, and internet. Okay, see why it is. You see, it is widely useful in the enterprise networking. Means in the companies. Why do we use IP security instead of VPN? Okay, VPN means what happens is there will be one private channel for you. See, usually to send some data there will be channels. Okay, so there can be public channel where everyone sends the data, which is insecure, or else you can be having a private channel where only you can send the data, no one else can access it. So this is more costlier. Okay, it will be very costly because for you only another wire is present. But what if instead of using a private one we use a public one only, but it is still secure? How can that happen? This can happen if you apply the encryption. Okay, if you apply the encryption, even if someone sees the data, nothing is of use to them because it is unreadable data and ununderstandable data. So encryption we are applying. That's what IP security does. It applies the encryption, making it useful in enterprise networking. Okay, now secure branch office connectivity. Organizers can create VPNs over the internet instead of relying on costly private networks. Got the point? Instead of relying on costly private networks, VPNs can be created which will be based on IP security. Okay, secure remote access. Remote users can connect securely to the company network by dialing into any ISP and then using IPsec. This avoids long distance toll charges and supports employee working from different locations. Security extranet and intranet connectivity. IP security helps build secure links with the partners or between the internal networks. Okay. Also, it ensures the authentication, confidentiality, and security exchange mechanism. So it is very secure. Okay. Strengthening electronic commerce. Okay. Although web or e-commerce platform may use their own security protocols, IP security adds an extra layer by ensuring all designated traffic is encrypted and authenticated. Okay. So What are these? These are nothing but the applications of IP security. Okay, what are the benefits of IP security? When IP security is deployed on firewall or router, it delivers strong protection for all traffic crossing the network boundary. Okay, internal traffic inside the organization does not carry the extra processing overhead of the security mechanisms. It is a highly restrained to a firewall using IP security is highly restrained to bypass. Okay, means it becomes even more secure. Okay, because IP security works between below the transport layer, it is completely transparent to applications. No user level or server level software needs modification. Okay, it can be just directly inserted and used. Okay, IP security operation can be transparent to the end users. Users do not require training in cryptographic method. It's not complex. Anyone can use it. IP security also can also secure communication for individual users when necessary. This supports remote application and allows organization to create secure virtual subnets for sensitive internal applications. So individual users also can use it whenever it's necessary. Now coming to the services, what are the services provided by the IP layer? IP security in the IP layer. Authentication header is given to ensure that whatever we have got is authentic. It ensures authentication and integrity. Encapsulating security payload. ESP provides encryption and can also offer authentication. According to the RFC, request for comment 4301. This means these are the set of rules defined how the policies should be. Okay. So it firstly it provides the access control, restricts communication to authorized users and systems. Whoever is authorized, they only can use. Connectionless integrity ensures packets do not alter during the transit, and data origin authentication confirms the true source of the received data, where the data has come from. That will be authentic. Okay, that information will be authentic. It can't be it is coming from hacker and they will not know it. Okay, so they have designed the algorithm in such a way. Anti-replay protection rejects duplicate data or replay packets using the sequence numbers. If two packets come back to back, and if it is the same packet coming repeatedly, it will be rejected. Confidentiality, it encrypts the data to prevent unauthorized viewing. And limited traffic flow confidentiality hides traffic patterns to reduce information leakage. Okay, next. Explain ESP packet format. Okay, just now we discussed the ESP, right? Encapsulation security payload. So what is its format? How it looks like? Okay, the overall structure is illustrated in the below figure. I'll show you. But before that, the main fields are security parameter index. Okay, what is SPI? It is a 32-bit index uniquely used to identify security association to process this packet. Okay, so it is an index number. Sequence number is a monotonically increasing counter that supports anti-replay protection. Means each packet will have one number, and the next number will be here, next number will be here, to ensure that a new packet is received and not duplicate packets every time. Okay, payload data variable length, what is the data needs to be transferred, that will be present as in the payload data section. Okay, and padding is used for alignment block cipher requirements to obscure actual message length. To hide what is the actual length, padding will be there, means some data will be put in front and back of it. Okay, pad length is 8 bits, specifies how many bytes of padding are preceding this field. Okay, next header is 8 bits, identifies the type of payload carried, whether it is TCP, UDP, IPv6 extension header, whichever the type of payload is carried, that it will be showing here. And finally is integrity check value, ICV. ICV is a computed value over the ESP header and encrypted portions, except authentication. It is required only when the integrity protection is selected and not using a combined mode algorithm. Okay, and when authentication encryption combined mode is used, algorithm returns both decrypted payload and pass fail integrity integration. Okay, so basically you have to make these two structures. They can ask you separately also, explain top level format or the substructure of a payload. Both have the same parameters, everything which we discussed. SPI is there, sequence number, payload, padding, and pad length, ICV. Here also the same things are there, padding, pad length, and network header initialization value. Okay, so whichever diagram they ask you, you have to make those diagram and then write those parameters above. Okay, next, write a note on IKE formats. Okay, so IKE header and payload formats. IKE stands for Internet Key Exchange Protocol. It defines procedures and packet formats required to establish, negotiate, and modify and delete security associations. Okay, it has the control to make all the changes to the security associations. As a part of SA setup, IKE uses a variety of payloads to exchange key generation and authentication data. Okay, so it has the capability to produce the data using which the key generation exchange will happen and authentication of the data itself will happen. These payload formats form a consistent and flexible framework independent of specific key exchange, encryption, and authentication method used. So these all things are what it is done by internet key exchange. So if they ask about the internet key exchange, you have to write these for these points again. Now the IKE header format will be as follows: security parameter index will be here, that is initiators. Next one will be the responders security parameter index. Okay, and here it will be the next payload. Here there will be a message id length, and here we'll be having major version and minor version, exchange type, and flags. So these are the points you need to make. Okay, and generic payload header, this is next payload c reserved, and payload, this is optional. Okay, you can just make this one. Okay, IKE header. Now these things we have already discussed in the previous one, the same thing you have to do, except few things are there, like what is major and minor version. Let's have a look at it. Okay, so IKE message is made up of IKE header followed by one or more payloads. Okay, means header will be here, and then the actual data will be here. The entire message is carried over transport protocol, and IKE supports requires support for UDP as default transport. Okay, IKE header contains the following fields: initiator SPI, which is a value generated by initiator to uniquely identify the IKE SA. Responder SPI, a value generated by the responder to uniquely identify the same IKE SA. So initiator SPI and the responder API should be same. Okay, and next payload indicates the type of the first payload in the packet. Additional payload follow in the sequence. Major version 4 bits specifies IKE major version being used. Okay, minor version specifies the minor version of IKE. Exchange type identifies the exchange type such as IKE SA init, IKE authentication, create child SA, or informational. Okay, next. Flags contains the initiator bit, version bit, and response bit. Okay, the bits including all of this information. And message ID contains the used for retransmission control and for matching request response pairs. The ID of the message will be present. Length is the total length of the complete IKE message, including header and all the payloads in octets. Okay, so including header and the payload, how much is the total length, that will be present here in octet form. Okay, next. Draw and explain IP traffic processing model for inbound and outbound packets. Okay, so IP traffic processing, it operates on every individual IP packet. Okay, the processing happens on every IP packet, ensuring both outgoing and incoming traffic passes through the required security checks. When enabled, IP security processes outbound packet before transmission and each inbound packet after reception, but before data is delivered to the higher layer protocol such as TCP or UDP. Okay, before it is delivered to such, it is checked if it is a proper one or not. Okay, so outbound, we will have to discuss both of them. Okay, outbound also and inbound also. So each of them have their own diagrams also and points. Okay, so let's have a look. How outbound packet processing. Outbound means the data is being sent from IP security to somewhere else. So firstly it is made secure, then only it is sent. So the flow of outbound traffic begins with a block of data from a higher level like TCP, which is handed to the IP layer to form an IP header and body. Once the packet is formed, IP security performs a series of steps. First one is SPD lookup, which is security policy database, to find an entry that matches the packet selector fields. Second, if there is no match, means it is an error. There is no SA associated with that. That means the packet is discarded and error is generated. It is an invalid packet. Next, if a match is found, means the policy is applied. Match is found means a policy is associated with that. The policy, if it is discard the packet. If the policy is bypass, then packet skips the IP security processing entirely and it's sent out normally. If the policy is protect, in that case IPsec searches the security association database for relevant SA and then it applies it. If it is not existing, it invokes to create an SA and install the necessary keys. Next is IP security transformation. Based on SAD entry, the packet undergoes encryption, authentication, or both, and either transport mode or tunnel mode is applied for the packet. After processing, the packet is passed to the network for the transmission. So these steps happen. So if you see in the diagram, the first you will be starting from here. Outbound IP packet comes, it will search for the security policy database. If there is no match found, it is discarded and goes to an error. If the match is found, the policy is determined. The policy, if it is discarded, again it's discarded. If it is bypass, it will directly send to the next layer. If it is protect, then it will search which protection should be applied. If a match is found, that protection is applied and sent. If it is not found, IKE creates a new policy and then again it is applied here and sent. Okay, this diagram is just for the outbound. Let's have a look at the inbound. Inbound, for incoming packets, IP security examines each one as soon as it arrives. The processing flow begins by looking at the IP protocol, IPv4 field, and the next header field, IPv6, to determine whether the packet contains ESP, AH, or IP security protection. The incoming packet is looked for any protection if it is present or not. If the packet is unsecured, IP security consults to the SPD, Security Policy Database. If the policy is bypassed, IP header is removed and the payload is delivered to the next layer. As simple as that. If it is a policy or discard, if no entry matches, then the packet is discarded. Okay. And if security packet is present as ESP or AH, IP security searches for SID for matching SA. If no match is found, discard. If match is found, appropriate ESP or AH processing is applied. Next, deliver to the higher layer. Okay, so this is also the same way. The input inbound packet comes from here. It is checked for the IP value. If it is bypassed, it will be directly delivered to the higher layer. If it is not, then it is discarded. And also it will check for the IP security if any association is to be applied. If a match is found, apply the association and send to the higher layer. If it is not found, discard it. Okay. Next, discuss basic combinations of security association. Now we have discussed, right, IP security generates SA security association. Now what are those security association? How to actually make it protected one? Okay, so IP security allows multiple security association. There are four of them. Okay, the case one is end-to-end security between hosts. Both hosts implement IPsec and share secret keys. Possible combination include AH or ESP, or ESP inside AH, or any of these inside and outer tunnel SA. Okay, if I show you the diagram, this will be clear. These support authentication, encryption, and ordered combination like auth before encrypt or auth after encrypt. Okay, these are the things you need to remember. What provides authentication and encryption. Okay, that is about end-to-end security between hosts. Second is gateway to gateway security. Hosts do not use IP security, only gateways to protect the traffic. A single tunnel mode SA is enough because the entire inner packet is secured. This is the basic VPN model. Okay, that is gateway to gateway security, which is also known as VPN. So gateways will be present in a single tunnel mode. Okay. Next, gateway plus end to end. Okay, the case one plus case two. If you include both, that also gives a very high level of security. It also offers traffic flow confidentiality. End to end SAS is present for extra confidentiality or authentication, and basically we will be having the gateway to tunnel SA. So gateway will be present inside this individual end to end SAS will also be present. Finally is the firewall, which is remote access through firewall. It is also network tunnel mode SA using with the firewall. It enables secure access to internal servers similar to remote access VPN. So the first diagram, first case is the one or more SAs. There will be a tunnel present here, and there will be a router which will be connected directly to the host, and the host will transfer data using the one or more security association. Next case is the tunnel, which is having the security gateway, and that security gateway transfers, not the host. Security gateway will transfer the data between the tunnels. Okay, that is also secure way. Third one is tunnel plus security. So security will also transfer the data in a bigger tunnel, and the host will transfer in a smaller tunnel, like that. Okay, and it is on top of it, the bigger tunnel on top of smaller tunnel. Next is case 4, wherein we'll have a firewall. Firewall is something like this. Host will be here, and the intranet local internet security gateway. Host will be connected to the two SS, and one of the hosts will be connected to tunnel SA. Okay, and security gateway will be always connected to tunnel SA only. This is the diagram you need to make. Okay, that's all for the CNS. Don't miss any of these questions. These are the most repeated ones. I've taken the questions from the 22, 18 scheme, 21 scheme, and yeah, 18 and 21 scheme, as well as the model papers of it. Syllabus is quite similar. It's little up and down here and there. So I have included that. So please do watch till. If you did not understand any concept, feel free to rewatch, and please do like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.